inshallah, we will discuss today how to create a 2D drawing and controlling the size, how to create our own border and title block, how to modify and make it customized, and link the attributes inside this title block with other parameters. How to add a new base view inside the drawing and create some projected views for that one, how to create a section, how to add a different type of dimensions, how to modify the drawing style and layers, how to make other detailing like breakout, slice, and group, how to make a print, and some examples for that. We will start with creating this sample to use it during the session of today. So during this step, we will revise the first session, which is 2D sketching, and the second session, which is converting the 2D sketch to a 3D model by using Autodesk Inventor 3D model features like extrude, revolve. After that, we will use the third session, which is making the assembly and using the assembly constraints. And the same with modifying the material properties for each item, defining the color and controlling the density of the material, changing the mechanical properties, all of that. On the fourth step, which is creating the fabrication drawing or detailed drawings for the assembly and parts, that's the task of today, inshallah. Now let's take a print screen from this image, and from here, this image, and start creating the first part, which is fixed jaw. So from here, let's create the first project. From project, let's create a new project, and from here, let's make English spanner. And let's create this project in the Day4 folder or the desktop, and click on finish. Now we have this project activated now, and from here, let's create a new part. Okay, so from here, let's select standard part, and let's create the first sketch. Here, if you take a look, this part is a circular part. Okay, so we can use it as a revolve to create this segment. This one is a rectangular section, and here we have another rectangular section. So let's create from top to bottom. From here, the total height of this one is 290 millimeters. So let's create a new sketch and select a plan to start sketching. From here, the tab of sketch will appear here, and the 2D instances will appear on that tab. From here, let's select align and define the length of this line as 218 millimeters. Okay. 218 millimeters. Now we have this line. Let's convert it to be a center line. By selecting it and select this option, we can convert it to construction center line. Now let's create the top cross section, which is that one. Okay, so from here, with the total length is 80 millimeters, and the end here is 23. Okay, so let's create a roughly sketch like that. Take a line here and create an arc with defined by 3 points like that. Now let's define this height as 23 millimeters. Okay, and move this one a little bit. Define this height to be 8 millimeters. The total length is 80 millimeters. So from this line to this line is 80 millimeters. Okay, now we have the rough sketch for this one, and we need to define the radius of this arc. It's 40 millimeters. Now we need to weld this line to at this point. So you can figure that now this face is constrained. This line is constrained, but not fully constrained because we can move it left or right. We need to define this length, which is 40 millimeters. So from here, let's make it. Okay. And define the offset from here to there as you can figure that it comes as a diameter. So we can right click and make it linear diameter to define this offset only. So here we define the this part as a solid part from here like that. So we can convert this line to a construction line. Now we have the ability to extrude this part. So from here, by using extrude, we can select the both closed areas. After that, give it a thickness in the two directions. As discussed on the second session, here the extrude will be above the plan, below the plan, and here on the middle of the plan. So let's define the width. The width is 23. So from here, let's come back and define the width as 23 millimeters. Now we have the top part of this one. Now let's create a new sketch. So let's select one of the origin planes, which is XY plane, and create a new sketch. Now we have a rectangle here. This rectangle is connected from the middle to this line, and the midpoint here is vertically with the center point here. And let's define the width of this one. So the width here is 20 millimeter, and the thickness of the other value is 12 millimeters. So it's millimeters here, and the height of this one, let's come here, the height is 55 millimeters. So let's come back here and define this height to be 55. Now let's give this sketch an extrude with 12 millimeters. Now, as mentioned, we will make this extrude in the two sides, modify the value to be 12 millimeters. Now we have this extruded part like that. And if you take a look here, we have a fillet here in those two sides. So let's define this value. It's not defined on the drawing, but we could make it as 2 millimeters or 5 millimeters. Okay, and click on save. Now we have this one. Now let's make the rolled section here. We have a rolled section at this area with a thread. So let's create the solid feature of this part. After that, create the thread on it. From here, let's select YX plan and create a new sketch. And from here, let's draw the center line, okay, from here to there, and convert this sketch to center line, convert the projected line to work line, construction line. And from here, let's draw a rough cross section. After that, add the dimensions for this one. Here we have this cross section. And now let's define the dimensions. The diameter of this one is 12. Here it's 2 millimeters by 2 millimeters. So the height of this one is 2. And height of this one is 2 millimeters. And the diameter for this one is 12 millimeters. And diameter of this one is 8. At bottom, it's 8. Okay, because here when we try to add this one, you can figure that you will receive this message, and Autodesk Inventor tell you that it will be over constrained because this line is already linear with that one. Okay, so now let's create a revolve. So from here, by using a revolve order, we can make a revolve for this cross section. Now we have this part like that, and we need to make a thread outside this surface. So from here, let's select surface and select that one. From here, you can select the thread type, asymmetric profile or isometric profile. After that, define the size of the thread and designation of the thread class and the direction of the thread right or left. Now we need to make this thread along this part, and if you would like to define a certain value like 50 millimeters, for example, you can do it like that. You can modify the offset. Let's make it 40 millimeter offset, but actually we need it with a full size thread. Now let's save this part as fixed Joe. From here, let's save this part as fixed Joe. And now let's define the material for this part and select suitable color. From here, if we take a look to this drawing, you can figure that the material of this one is steel 70. So to define a material like that, we will select a near material for that, which is steel, which have the same density and near mechanical properties. After selecting it, you can open the editor of the material, and from here you can make an edit from this one, or you can duplicate it and keep the original material here. Select steel one, which is a copy from this material, and you will find the list here. After that, you can make an edit for this material. When you click on edit, you will receive this form, which is material edit. And from here, you can define the material name, which is steel 70. Okay. After that, you can change the description of this material and the type. If it's a metal or wood or glass, it's a metal. So, and from advanced, you can change the color of this material. So you can select a picture to present the feature of or the surface of the material, and from the physical properties, you can modify the mechanical properties like basic thermal properties, or the mechanical properties like Young's modulus, Poisson's ratio, shear modulus, and density. We will keep the information for the mechanical properties as they are. After that, let's click on OK and close this one, and you can figure that the material name here is to steel. Now we need to change this color a little bit. Okay, so from here, that's the color of the material. You can select a near color for what you need. So you have a list of colors for standard colors, and if you would like to add a special color, you can do it from here. Select one of those and make some modification to make it suits your requirements. We will select the steel color. So from here, let's select steel. Now we have we can change the material and color of this part. Now let's click save, and from the eye properties of this part, you can make it appear on the quick access toolbar by clicking on this button here, and you will get this list. This list includes the features that you can include it on the quick access toolbar. One of them is the eye properties. So we will include the eye properties as a new button here on the quick access toolbar. So now this is the eye properties will appear here. Okay, and you can get it, by the way, from the file button. So from here, from this list, you will get the eye properties. So you can get from the quick access bar or from file. After that, from physical properties, you will find the material of this part, and you can make update to update the mass of this part. It's around 0.5 kilograms, and here the total surface area and the volume of this part, and here the initial properties around the principal axis or global axis or center of gravity. And you can use that, by the way, if you would like to make some manual mechanical calculation. So here we have the first part, which is the fixed tool. Now let's create another one from standard part, and let's click on create. From here, let's select create 2D sketch and select a work plane. Now let's create a center line for the second bar. So let's make a zoom for the movable jaw. So from here we have this, sorry, again, we have that profile. From here we have, if we take a close look here, we have a circular piece here, which is that one. Let's move the color. So from here we have this part, which is a rotated part, but we have here longitudinal ribs. Those are two longitudinal ribs, which is they are those, and two other ribs here, which is they are those. So we will need to make some different features to create this part. So let's start with the two ribs here. So let's start with those longitudinal parts or pieces. So from here, let's define the total height. The total height is 90 millimeters. So from here, let's define this length is 90 millimeters, and let's make this part or this line as a construction line. Now let's define the dimensions. From here, let's make a rough sketch for this one. Make an arc by, if you select the end of this line, you can figure that the point color change to gray if you comes near to the end. When you make a drag and move, you can make an arc, and that we discussed it on the first session, which is sketching. And now let's make a vertical line, another chamfer edge. After that, make a line like that. Okay, so we can weld or make a trim for this line. Okay, make another line here, another one to inside. After that, draw the second part here, like that. It's straight with chamfer at the end and this line. Now you can figure that the end here is not fixed, and we need to align those with each other. So from collinear, we can make a collinear for those lines, and by using horizontal, we can make the level of this node or this point with the level of that one. So you can figure that the end of this one in the same level. The same we can do it at the top. Here, as you can see, this one is movable. So we can weld this point to that line like that. And you can figure this sketch. Now we need to modify it. So you can move it down like that and change the arc length by moving this line a little bit by hand. And now you can modify the dimensions. So from the center line to the edge is 45, and the total length is 70. So from here to there, it's 70. And from here to that edge is 45. Okay, now we have this one like that. And let's define the height of this edge. So this edge is 8 millimeters. That one is 8, and from here there is 10 millimeters, and the arc is 15. So from here, let's define the arc to be 15 millimeters. Okay, now you can figure that the sketch is fixed at the top, and we need to make this line. If you take a look, you can move that right and left, so we need to add more dimensions to fix this sketch. So from here, if we take another look from here, the total width is 50 millimeters. So from here to there is 50 millimeters, and the inside here is 20. So from here to there is 20 millimeters. And for one side, it's a half value. So let's select this value and divide it by 2. Now, those lines now are constrained. If you take a look, we have 2 chamfers at the end here, and we need to make them equal. So from equal, let's select this line and that line and make them equal. Now let's define the angle, which is 45 degrees. So let's come back and modify this value to 5. The same on the other side, 5. So you can select this one directly to make them equal. And now we need to modify the value as 9 millimeters. So here it's 9 millimeters. Now we have this profile like that. But one more thing we need to do, which is if you take a look, a close look here, this edge is not a straight edge to the end. That one, it's not straight. One we have here and a cut as a whole. After that, we have an straight edge like that. So let's modify the line here and make changes this contour at this area. So from here, let's convert this line and that one to a construction line. And let's create another line from here and make drag and move to make a part of circle by using drag and move. And now let's make a line up to the end. Let's convert this line to construction line and close the sketch at this area. Now let's define the dimensions here. So the hole at this area at the inside here, from here to there, it's 22. So the diameter here, so let's change the value from here. It's 22 by 2, and the whole diameter radius is 1.5. So the radius of this one, 1.5, and the elevation of this one. So the elevation of this one at 30 millimeters level from the bottom. So let's measure this one from here. It's 30 millimeters. Okay, so if we take a look again now, I think it's okay. Now we can make the same thing on the other side. So let's come back here and create new line from here to there. Drag and move to make a part of circle like that, and make a vertical line. Convert this line to a construction line and close this area. You can select those circles and make them equal from here. The same for that one and that one, and make them equal. Okay. Now you can figure that this line can be moved right and left, because we need to define the offset from here. So the offset from here to there is 22 millimeters. Now you can figure that the sketch is completely fixed. Now let's make an extrude for this sketch to create those parts here and that one. Okay, so come back here, and from finish, let's click finish. Okay, and make zoom extend to make all the sketch appear. And from extrude, let's select this closed area and that closed area. As mentioned, we need to make them symmetric around the origin plane. And from here, let's define the width. It's 12 millimeters. So let's define the width of this one. It's 12. After that, we need to make the outer rib, which is that one, in 2 sides. So it's right and left. Okay, so to create it, we can select that face, and from here select create 2D sketch. And now we can make a project geometry for that. So select those lines, convert that one, and close the sketch like that. So that's, as you can see, it's the section here. And for the yellow colors, which is created by using the project tool, we can convert all colors in this sketch two blue colors to make them visible in a good way. After that, click finish, and from extrude, let's select this closed section. And from here, you can figure that the width of this one, it's the difference between 23 and 12. So you can calculate it by that way, which is 23 minus 12, and that value divided by 2. So you can calculate it after that, import it directly to Autodesk Inventor, or you can calculate it from here, from that form, which is 23 minus 12, all of that divided by 2. So here the value will be calculated automatically. Now click OK. Here you have this side, and by using the mirror feature, you can select this feature from here, and you can make a mirror around one of the origin planes. So if you select YZ plane, you can figure that it's not the correct plan that you want. And when you select the YZ plan, it's not the correct one. But when you select the last plan, which is XY plan, you can figure that it will give you the good result on the other side. Now let's click on OK, and now we have the top part of this one. We need to make one more piece here, which is a circular piece here. So let's come back to the sketch, and from here let's select one of the origin plans, which is XY plan, and create a new part here. So from here, let's make a closed section like that. After that, let's define the dimensions. Let's convert those to construction lines and that one to a center line. Now let's define the inside diameter. Here the inside diameter is 22, and the outside diameter of this one is 32. So the inside from here is 2, and the outside is 32. And the height, now the sketch is disappeared. If you would like to make it appear again, you can right click and select slice graphs, or from shortcut you can click on F7 from the keyboard to make a slice graph, which will give you the ability to make a cut on the 3D model and give you an access to watch the or edit on the sketch. So from here, let's define the height to 30 millimeters. So from here, define this value as 30 millimeters. Now we have this sketch, and from 3D model, you can make a revolve for this sketch. Now we can get that feature like that. Now we have this part, okay, and we need to add one more thing here, which is the holes. Here we have two longitudinal holes. Those are the holes, which is they are suits this tapered bin. Okay, so from here to create those sketches, we will need to select another plan, which is XY plan, and create a new sketch. Now let's create a slice graphs, make a slice graphs, and define the hole offset and dimension. Now from here, the hole diameter is 2.75. So from here, let's find the hole diameter 2.75. Now it's, as you can see, it's floating hole. We need to define the location for this one. From the bottom, it's 15, and from the center line, it's located on the edge here. So from here, we need to print this edge. Okay, so we need to print this line. After that, locate the center line of this hole on that line. Okay, now this hole located here, and we need to modify the offset from the bottom. It's 15 millimeters. Now you can figure that this hole now becomes with a blue color, and you can figure that on the status bar, it's fully constrained. Now we need to make a cut. So from here, we can select extrude, and now we need to make extrude cut through all and make it through all on the two sides. So the cut will goes along the solid part like that, and let's click on OK. We need another hole here. You can do it by two ways. If you come back to the sketch here, you can make it inside the sketch by making a mirror or draw another circle. So you can make another circle here and make them equal, or you can make a mirror by creating a line at the middle. After that, create a mirror for this circle around that line, so you will get another circle. After making it, you can edit the feature. So from extrude, you can select the other solid, so you can make it like that by editing on the sketch and creating another hole. Or you can make it by using the mirror feature. So we have a solid here, which is that feature. It's a solid, it's a cut, extrude cut. So by using a mirror, you can select this feature and mirror it along the YZ plane. So you will get that cut on the other side like that. Now let's save this part here and name it as a movable jaw. Okay, and let's change the material of this one to steel and the color to steel, and modify the material name from here by taking duplicate this material and to keep the original material as is. And from here, let's make it steel 20. And if you would like to make any other modification on the physical properties or in the color, you can do it from here, but we will accept it like that. And from here, the material will appear here as steel 70. Now, after saving this part, let's proceed with the, another part, which is the third part, which is the handle. Okay, so let's do here. Okay, that's the handle. It's all the section of this part is symmetric, so we can make a one section and make a revolve for this section to create this part from one feature, which is the revolve feature. So now let's create a new part. So from new, let's create a new part, and from sketch, let's create the center line, and from here the center line or the total height is 150 millimeters. So from here, let's make a line 150 millimeters. So that's the center line of this one. Let's create the inner surface of this one. We have a straight line here. Okay, after that, tilted line, another straight line. After that, we have another break here. So let's make a rough contour for that. So let's come back to Autodesk Inventor. We have a tilted line, another vertical line like that, and here finally we have that profile. So now let's define the dimension. So the inside diameter here is 12, okay, and here 21, and the angle here is 120. So let's define the first one. Let's convert this to a center line, not a construction line. And from here, let's define this to 12, 21. And the half of this angle is 60 millimeters. Okay. At the bottom, here if we come down here, it's 24, and the height is 15. So it's this height is 15, and the inside diameter is 24. Okay. After that, let's define the straight height. Here is 85 for this part. So when you define this one as 85, now you can figure that the sketch is this sketch now is fully constrained. Let's convert those lines to construction lines because we will use them as a reference line. So here, let's make the outer sketch. The outer sketch is a little bit containing a lot of lines and arcs. So let's make it step by step. So from here, let's make this those 2D instances, line, another line, after that a half of circle, another line, and perpendicular line. So from here, let's make this one like that and click. After reaching this point, let's drag and move to make a half of a circle. Okay, by using a line. After that, define this edge like that. Now let's define the dimensions. At the top, we have 22 millimeters. So this diameter is 22. Okay. After that, the circle here, the diameter of this one is 2.75. So let's define the diameter, not the radius. So from here, you can select the dimension type as a diameter, 2.75. So that's the diameter. Okay, and the total length here is 30, and the half value is 15. So from here to there, 30 millimeters, and from the center here to this edge is half value. You can write it 15 or make an equation. Now we create this up to this point. Now let's define the other dimension for this one. So the outside diameter of this hub for this handle is 32, and the height from here to there is 6 millimeters. So by using diameter, we can select that as 32. And from here to there, let's define it as 6 millimeters. Okay, now let's make another, as you can see on the sketch here, we have some fillets. So let's keep them up to the end after creating the sketch. So let's come back here, make this one a straight edge like that, make another one, and now we have this contour at this area. Now the height from here to there is 8 millimeters. So from here to there, it's 8 millimeters. Okay, and from here to there, it's 4. Okay. Now let's add the fillet. Now we have 2 millimeters fillet here and there. Let's define this diameter first, which is 24. So from here, it's 24 millimeters. And let's add a new fillet and modify this. We have R2, R2, and R3. So let's make it R2 millimeters, which is this corner, that corner, and 3 millimeters at this corner. Now we have that sketch defined it, and the diameter of this one we need to define it. So from here, let's come back and check the outside diameter. It's 34. So from here to there, let's define it as 34. Now the sketch is completely fixed. At this point, we can move it down here up to the end and close this sketch at this end. Now we have that feature. If we click finish sketch and zoom extend, by double clicking on the ruler on your mouse, you can make a zoom extend. Again, when you take a view like that, you can make a zoom extend by double clicking on the ruler, or you can make it from here, zoom all from the view toolbar. So from here, you can make a zoom all. Okay, now let's select a revolve feature. Automatically, you configure that the revolve feature select all this, the closed sketch and the center line. Now let's click on OK. Now we have this feature. Let's change the material to steel. Now the color to select any other color, like let's select beige color. So we have this beige color, and we want to make 2 more things here. If you take a look, we have a thread in this area and another thread at bottom here. So we need to make a thread at top and bottom, and we have this surface as a rough surface. So we still need to modify first thing, let's modify the material of this part. So let's duplicate this material and modify this material to steel 0.42. Here, if we take a look to the material list, here the handle material is steel 42. Okay, so let's come back again to top, and let's add a thread here and another thread at the bottom. And now let's click on OK. Now the material is steel 42. Now let's add a material, another color here. So let's select this surface, and from here let's select properties. So from here, that's the property of this face, and from here let's select this type of color, which is expanded material 0.1, and click on OK. Now you can figure that this color is a transparency color. If you take a look, you can see what inside. So to remove this transparency, let's modify the color, this color. So from here, we have the expanded material, and by editing it, you will get the material editor. So the appearance editor. So you can modify the material from here. And if we open this form, you can remove this option, which gives the transparency or make the white color as a transparent area. So let's remove this checkbox, and now you can figure that this surface now become without a transparency option. You can extend or increase the size of this one. So from here, if we click on edit, and here the edit form, if you click on generic form, you can increase the size of the sample. So you can insert an image here and make a modification for that bar. If you would like to increase the size of this one like that, and if you would like to remove the look here and make define the height and width to make it looks like 45 or something like that. So you can make a link between the values, or you can remove it. So from here you can change the size of this rough image on that part. Now let's create a thread. So from here, let's select from the modify feature, let's select a thread and select this surface. Inside, from here, select the standard type, the thread type, size and designation, class and direction. And let's make it through all. Click OK. Now another thread at the bottom. Here we have thread at this area, and let's click on OK. Now we have this feature or that part done. We modify the material and color, create the 3D model. Now let's click on save to save this part as a handle. Save. Now let's create another part, which is the plug. Here we have another part number 4 is the plug. It's the same. We have to make a revolve for a section. After that, we have 2 small cuts here and there. But the main feature we can create it by using revolve. So from here, let's create a new standard part, and from here select this one, and here define the height. So the height of this one is 22. From here, let's define the height as 22 millimeters. Draw the section. We have a chamfer here, another sharp edge, and that's the contour of this one. By drag and move, you can make an arc, and the same another arc up to here. Okay, this point we will weld it to the line, the extent of this line, because this arc tangent to that one, and that arc is tangent to the perpendicular line to that one. So by making the center line located here, you can make this tangent, this arc tangent to the perpendicular line here. Now let's add the dimensions of this one. The top diameter is 24, and the height here is 10 millimeters. So it's sorry. We need to modify this line to be a center line. So from here, select it and make it as a center line. Now, when you try to add a dimension, you will make it like that. Now we need to change this one a little bit, and one here. From here to there, it's 10 millimeters. And the gap at the bottom is 1 millimeter, and the chamfer 1.5. So this value is 1. and this angle is 45 and the height is 1.5. So you can figure that the color of lines is changed to blue. That means this area is constrained. Now we have those lines still, we need to modify them. So it's here, it's 20 millimeters at the bottom and 34 for the diameter. So this one is, and from here to there is 34. Okay, now we need to define this figure. So when we come back here, the radius here is 8 millimeters and the other one is 24. So this one is 8 millimeters. And if we try to measure this one, we can figure that it's a fixed value because the other dimensions are fully constrained. So the value on the drawing here, you can figure that the value here is not the correct value. Okay, and if we try to measure the height here is 12. So you can figure that the drawing, the 2D drawing, it's not a correct one. So here that by making a fully constrained sketch, you will get this profile. Now let's click on finish sketch and make a revolve for this part. So from revolve, let's make a revolve here. After that, we need to make a cut area here, and the gap between them is 82. So to make a cut here, let's select this surface and create a new sketch. And from here, make a 2 rectangles like that, and make those lines equal and those lines equal, and align them in a horizontal position like that, and with the center point. Now we need to define the width. The width is 4 millimeters. So the width from here to there is 4 millimeters. And now the sketch is disappeared inside the solid. So as discussed, you can make a slice graphs from this shortcut menu, or you can click on F7 from the keyboard to make the same one. From here to there, the spacing between them is 28. So it's 28. And from here to there, it's the half value. So let's select 28 and divide it by 2. So here it's 14 and that one like that. You can control that length or keep it 3. Let's make it 10 millimeters to make everything constrained. After that, we will use extrude order to make a cut along this part. Of this cut is a cut, not a joint. So from here, let's make a cut and let's make it through all to be sure that the cut will go through the solid feature. From here, now we have this one. One more thing we need to do, which is adding a thread here. So from here, we have, as you can see, we have a thread at this area. So by using a thread feature, let's add a thread at that one, and let's click on OK. Now let's save this one as plug. And from here, let's modify the material of this one. So let's select steel and change the color to steel. Okay, or change the color to, let's select another color like rubber blue. Change it to make this color as a blue, like that. And now let's modify the material name. So from here, let's select this one and duplicate this material and modify the coupled material to steel. Look here to the material of this part, material of the plug. The material of the plug is steel 34. So from here, it's steel 34. Like that, and click apply. Now let's click on OK, and the material will appear here, steel 34. Now, if you would like to change a color a little bit, for example, you can go inside the color like that and make a modification for the color gradient by adding another, make this color darker or change totally the color from here. But after saving this, we still have one more part, which is the tapered bin, which is that one. As you can see, you can draw this part by different ways. You can make an extrude for a hole with 3 millimeters and make extrude with 20 millimeters. After that, make during the extrude make a taper, or you can make a revolve for the total cross section. So let's create by the same the two features. The first one by making a circle with 3 millimeters. For that, we can extrude with 20 millimeters length, and here from the taper you can define the taper value as a 1 degree, for example, so you can get that tapered shape like that, or by creating by using the revolve feature, by using drawing the, if we take another section here, and if you make a center line like that and define the top diameter, bottom diameter, sorry, let's make weld this point here and make this one as a horizontal line. Sorry, this line to be in, this line to be horizontal. Define this one as a center line. Define the value here as 3 millimeters, and the height 3 millimeters, and the diameter at the top, let's make it 2.5, for example. So you will have a tapered cross section. After that, you can make a revolve for this one, so you can get the same result by using the two options. Now let's click on finish sketch and delete the second one, and you can make the same by using sweep order here, by making a path for a line and make it tapered. But extrude is the most easier one to do that, by making one diameter and make extrude with tapered angle. So let's save this part as a tapered bin. So and save this part. Let's change the material to steel. For that, modify the material to suit the bill of material here, which is steel 34. So let's duplicate this one and modify the material to steel 0.34 and accept this. Change the color to red. Okay, now we have this bin and save it. Now we have those 5 parts, and we now need to make an assembly to collect them inside this assembly and making some constraints. So from here, let's create a new assembly by clicking on new. From here, clicking on new, or if you open the this button for the quick access toolbar, you can create an assembly directly from here. After that, let's place the components, select place, and from here let's select fixed jaw. And now you can figure that the fixed jaw, you can move it any place on the 3D world, but we need to add it on the aligned with the origin plane. So from here, let's right click and select place ground at origin to add this part aligned with the origin planes. Here, what does that mean? That means here you have some origin planes for this part, which is YZ plane, XZ plane, XY plane. Those planes will be aligned with the origin planes of the assembly. The assembly itself has the some origin planes, the same origin planes. So you will make this plane laid on that one, and XZ plane laid on XZ plane for the part. So this part will be completely fixed, and you can figure that you have a bin here at the icon of this part. That means this part is now fixed. If we take an image here, you can figure that we have this bin located on this part. That means it's fixed without making any constraints. Now we have, no problem. Now we need to make to add another part and assemble it. So from here, let's add the movable jaw. Now you can put it anywhere on the 3D world, and you can figure that you can move it anywhere. And from view, you can activate the degree of freedom. Now you can figure that this part has a 3 degree of freedoms in X, Y, Z, and another 3 degree of freedoms for rotation around the original axis. So totally you have 6 degree of freedom. Now we need to fix this part. We need to make one more modification here. If we take a look, we have a fillet at the end, at the top here. We take a print screen again and mark here. We have a fillet here at the end. That fillet, we need to modify it to add it on the drawing. So the fillet value is around 5 millimeters. So let's come here and open the movable jaw part. And from here, let's select the fillet and select those two edges and modify the value to 5 millimeters to create a fillet at those edges. And let's come back again to the assembly. Now let's add the first constraint. As you can see, that surface, let's select constraint from the assembly tab. So we will get the assembly constraint form. So from here, let's select this surface. So that surface will be made with that one. So if you take a look, this part will be, you can move it along that one up and down. And if you take a look from the other side, you can move it like that. So we need to add some other more constraints. So from here, let's select that surface and make it mate with that one. Okay, now you can figure that the degree of freedom, you can see the green arrow here. You have 1 degree of freedom for this part, so you can move it up and down only. If you take a look from the other side, you cannot move it right or left, just up and down. So now you have 1 degree of freedom. Now let's add another part. Okay, so from here, let's add the handle part. Okay, and for the handle part, let's select one other constraint, which is insert. So by using the insert, let's select this edge at this point and make it inserted with that surface here, that circle or that circle, the same. So you can figure that you can insert this part and still you will have 1 degree of freedom for this new part, which is the rotation. So you can rotate it around the original axis. Okay, now let's add the other 2 parts. So from here, let's add the plug. And we have this plug here. And by the same way, let's make a constraint. So let's use 2 other constraints, which is this center line with that center line. Now you can figure that this part, you can move it up or down like that. And you can rotate it because now you have 2 degrees of freedom for this one. One more constraint, which is make this face mate that face. And you can, as discussed on the previous session, you can define an offset. So for example, if you would like to make an offset by 1 millimeter or 10 millimeters, you can do that. But the value here is 0. Let's click OK. Now we have that part completely assembled here. Now let's add another 2 pins. So from here, let's select the tapered pins. As you can see, each part has 6 degrees of freedom by constraint. Let's select the center line of this one, the center line here. Click accept, the same for that one. Now we have those pins like that. Click on apply. And by selecting the flush, let's make this one surface flushed with that one. So when you move one of them, you can move the other one like that. Okay, so let's fix this pin. Now if we open the tapered pin, and we need to make a work plane on the middle to fix it with the mid plane on the assembly. So by selecting a plan or selecting mid plan, so you can make a mid plan between those 2 surfaces. Now we have a mid plan here. Okay, so we can use it on the assembly. If we move this one a little bit out here, you can figure that you have a mid plan here. So this mid plan, we can make it flushed with the mid plan here. We have on that one, so we can make this plan if we print screen like that and make a new image. So here we have a mid plan at the middle, and we have a mid plan here. So we need to move this one. Sorry, we need to move this plan to make it aligned with that one. So from here, let's select constraint and select the mid plan here with the origin plan, and select the flush. And now you can figure that the bin now fully constrained, but we still have 1 degree of freedom, which is rotating it around itself. It's not an issue for this part, no problem if it's rotate around itself, because it's cylindrical part. Here we need to add one more constraint to fix the direction of the jaw. So we need to define an opening here. So from constraint, we can select this face and that face. Now this jaw is completely closed, and we can define an offset here. Let's make it 20 millimeters. So now the opening of this one, so we define the offset from here to there as 20 millimeters opening. Now let's click on OK. Now, if you take a look here, this part still have a 1 degree of freedom, which is rotating around the axis. To fix it, we can use one of the origin planes. Here, if we open, let's collapse all files. And for this part, which is Slug, when you select it, automatically you can figure that the color will be changed here on, it will be selected on the tree. So if you open this part, you can figure that you have the origin planes of this part. If you check them, you can figure that you have those origin planes. So you can use one of those like YZ plane and make a constraint for this one with one of the origin planes of the part like that. So we select those two planes and make a flush for them. Now this part, if you take a look, no degree of freedom for this part. Okay. Now let's start creating a drawing and save this assembly at first as English. Okay. And here we have this assembly. After that, we will use it in our next drawings to discuss how to make the drawings. Okay, now for the on the next slide, we will discuss how to create a new drawing, how to deal with the drawing size, increasing the size or change the size from millimeter, or select an English size like A, B, size of the drawing, or A1, A2, A0, or A3 drawing size for the metric sizes. How to create a new border, our own border. How to create a new title block and define the parameters. How to create sketch samples and use it inside the drawing. Now, when you open a new drawing, you will find here on the drawing resources some sub folders like sheet format, borders, title block, and sketch. Now let's create a new drawing. So from here, let's open a new. And from this form, by the way, you can change the size of icon to detail, list, or small icons, medium icons, or large icons. It's up to you. So like in Windows. So from here, we will select a standard drawing with extension IDW and click on create. Now we have this drawing, and when you open the drawing resources, you can figure that you have some subfolders here. Those folders, the first one, which is sheet formats, which includes the size of the drawing and the orientation of this drawing if you would like to make it portrait or landscape. And to change the size of the drawing, you can do it from here by selecting the sheet and right-click to get this shortcut menu. And from here, you can select Edit Sheet. Okay, now you have this form to edit the sheet properties. From here, you can change the sheet name, okay, like naming it as a general arrangement or any other name for the sheet name. From here, you can select the size, and you will find some standard sizes, metric sizes, like A4, A3, A2, A1, A0. Or you can make a custom size in millimeters, so you can define the height and the width of the drawing. And if you select one of the standard sizes, automatically you can figure that the height and width automatically defined, it depends on the size here. So if you select a custom size, the values will be available to modify. And here some other standard sizes in inch values. So the value here, which is 8.5, will be defined in inches. So those are the English sizes. Let's select A2 size drawing. And for the on the second part on the right hand side, you can define the revision number of this sheet. So you can add it as a revision 0, revision 1, all of that. And from here, you can change the title block location. You can make it on the bottom right side or bottom left side. So if you change it like that, the title block at the bottom here will be on that side. You can make it at top right or top left. You can change the orientation of the drawing to make it portrait or landscape. Okay, you can exclude this drawing from counting. Like if you have, let's say, 10 sheets inside this drawing, you have 10 sheets, you can exclude this sheet from numbering. So if you arrange the sheets, it will appear like sheet 1 of 9 instead of 1 of 10, because totally you have 10 sheets. But if you exclude this sheet from the sheets, it will be as a 9 sheet, for example. And you can exclude it from printing if you would like to exclude this sheet from printing. Now, if we click on OK, you can figure that the size of the drawing changed. If we make undo, okay, and redo, you can figure that the size of the drawing changed. If we change the orientation of this sheet, like make it portrait, and change the location of title block to be at top left corner, you can figure that the orientation changed to a portrait instead of landscape, and the title block becomes at the top left side. Let's make undo, and now we have this that changed like that. Okay, now let's create our own border. So how to make something like that? You have two options. If we take a look to the slide here, this slide, you can figure that you can select the borders folder and create, define the new border, or from manage tab, you can define the new border. So from here, let's define the new border by clicking on here and define the new border. And by the way, you can delete here on sides this resources. You can make a list of borders and a list of title blocks, different title blocks. Anytime you would like to replace, you can do that. So from here, let's delete the first. Let's delete the title block, border and the title block from the origin sheet. So this sheet, as you can see, not including anything right now. No border, no title block. Okay, now let's add a new border. So from here, let's create a new border. And now you can figure that you have 4 fixed points, because those points will define the size of the drawing. So the border that you will draw don't define height and width. Just reference it to the those fixed points. Like here, if we, for example, if you make the border like that, don't define this value as 570 millimeters. Okay, and that height, for example, is 390, like that, because let's check this after importing. Let's new define this border name. Let's click on cancel, and when you try to save this border, you will get this form. Now let's give this border a name like new border. Okay. Now if you insert it, now we have this new border. If you insert it to this sheet, Now you can figure that this border will activate it here, and it will be included in your sheet. So this sheet now includes the new border. Now if you try to change the border size, like make it again as A3, the border will goes out the sheet. Or if you would like to increase it, make it A1 instead of A3, the border size will be smaller than the drawing size. So the correct way to define the border size, which is defining it or make it reference to the origin points. No, so let's make it and let's delete those dimensions and make the size of the drawing referred to the fixed point. So from here, let's make this as a 10 millimeters, and from that corner 10 millimeters. The same from that side, make them in, and that one to be 10 millimeters. Now we have the border like that. You can add anything here, like adding an arrow. Let's add a rectangle. So from here, a triangle. So from here, let's add a triangle here like that, and make this point welded to the midpoint here, and make that line a horizontal line. Define the height of this rectangle like that as a 5. Make a hatch for this value and make it solid. Okay, like that. So you add something like that. If you would like to add a text like SEG Solutions. Okay, so this text you can rotate it, make it all upper lines, or you can rotate it vertical or horizontal. So let's make it like that and rotate it 190 degrees by using rotate. From here, select a point and rotate this sketch 90 degrees. So now you can move it here. For example, define the location of this sketch. So that one located from here as 3 millimeters, and from here to there is 1 millimeter, for example. So you can define your, create your own border and make it suit your requirements. Now, when you save it, you will get this border like that. And when you try to change the size of the drawing, let's make it A4, for example, the border will suit the size of the drawing, because the dimensions of this border referred to the fixed points on the border outside dimensions. Now let's increase the size. Let's make it A0, for example, so you can get the size like that. Now let's make it A2. So from edit sheet, let's make it A2 again. Now we have this sheet like that. Now let's create our new title block. So from here, let's select create title block, or from manage, you can define your new title block from here, or from the shortcut menu, define the new title block. Now let's create the title block. Let's define the width of this one, 103. The height, let's make it 80 millimeters. Now let's add a row at the top like that, and let's import a logo. So from here you can insert an image. Okay, so from images, let's get an image to use it in drawing. So from logos, let's go here and select this logo, this one, and let's go inside the project. Okay, so we have a project here, Day4. Let's add this image here. Now, when you try to include this image, let's select that one and let's import the drawing like that. Now you have this this image, so you can minimize it like that, move it to the areas that you would like to include. Okay, now we have this logo right here, and let's define the dimension of offset of this one as 52 millimeters. Okay, so this here, let's increase this one 3 like that. Now let's divide this one like let's add a text here for the project. So from here, let's create a text like project name. Okay. And we need to add a value here. This value, we need to make it as a, let's say, linked to the border as a parameter. You can modify it. So in that case, we can make some custom parameters here for this drawing if we finish it. And let's save this border as a new title block. Here, after that, let's include it to the drawing. So let's insert it. Now we have this title block. We will complete it, make another attributes. But here I would like to discuss how to add a custom property. So from the eye properties of this drawing, you can open the eye properties from here as discussed, or from file and select eye properties. And from the custom tab, you can add some custom properties. So those custom properties, you can change them, and you can move this drawing from project to another project and just edit the values from here. It will be reflected to the border. Like from here, let's add an attribute or a parameter called custom parameter called project name. Okay, and let's define this project as new Cairo project. And let's click on add. Now we have a new custom parameter here. Let's add another parameter as a text parameter. You can add a date, number, or yes or no as a true or false parameters like revised for construction and checkbox yes or not. So you can make something like that or make it as a number or a date. So let's make a text and make the client name. Okay, that's a new parameter. Let's make it SEG Solutions. Okay, and click add. Now we have two new parameters here. So we need to use them here on this border. So if we make an edit for this border, and now if we click here, now you will find in this list, take a look at this list, which is the properties. If we take a look to the properties here, let's increase this slide a little bit. So from 5. Okay, from here, you can figure that you can get the properties of the item. Here, that's the properties of the drawing. You can select between different properties here. You can select the model property, drawing property, or custom property for the drawing, another drawing property, sheet property. We will discuss all of that and use a defined properties here. For example, if you select the property from here and select property as a drawing, you can figure that you can add some of those properties, the standard properties of the drawing, like author, like company, comments, keywords, or manager. You can add some of those parameters. So where they are of those parameters. So if you open the I properties here again, from the summary, you can find those parameters here, like title, subject, author, manager, company, category. So those fields are a standard fields. You can fill them. After filling them, you can reflect the values in your title block. And if you would like to create a custom property, we discuss how you can create a custom property. So from here, let's come back again and add a custom property. So from here, let's select custom property for the drawing. Here you will find the attributes or parameters that you generate, like client name and project name. Let's select the project name, and by clicking on this button, which is add text parameter here, you can figure that you have a new parameter, and you can figure that if we take the screen like that and this one, and from here, if you take a close look here, we select the custom property. After that, select the project name. After that, import it from here. And you can figure that it will appear like that between brackets. And here the project name, which is that name, will appear here between brackets. So when you change the value, it will be reflected here. So let's check that. Now let's change the property name, and let's change the size of the text as 2.5. Now we have this project name. We can align this height. Let's make it millimeters, and this one on the half middle, on the half of this width. So let's find this offset at 2 millimeters. Now if you finish this sketch, automatically you will get this value, which is new Cairo project, which is defined here on the custom properties. Now if you try to change the value of the project name, like R2, like that R2, automatically it will be reflected here. So anytime you would like to modify the value of the custom property, just open the custom property and modify the value. Now let's add another attribute or another parameter. Let's make an edit. So sorry, for the title block, not the border. So from here, let's add a space before this one, like that, and let's add a client name. So from here, let's add client name, and let's add a custom property. So from custom property, let's add project name, client name, and let's insert the client name. Now we have that one. Let's change the size. So let's select all of that, change the text size, make it all centered on the middle, make this point vertically to that point, and adjust the location of this one to be equal that value divided by 4. Same from here to there. If you would like to make everything constrained or aligned. Okay, now let's make another property here, like adding a sheet revision. Okay, so let's add a revision here. Okay, so this revision, let's make it centered. So from here, let's make it centered like that. Define the height of this line. Let's make it 10 millimeters, and the offset from here to there is 2 millimeters, and from here to there it's half value. Okay, now let's increase this area a little bit. So from here to there, let's make it. Now we want to add the revision to here. Now you have 2 options for the revision, or let's say 3 options, by the way. The first one, which is if you open the standard properties, and from the from here, from the project tab, you can figure that you have a revision number for all the document, which include, let's say, 100 sheets. By the way, you can insert a lot of sheets inside the drawing, but let's say that revision will be for all of the drawing document, not for a separate sheet. So if you have the same drawing number for all sheets, you can define it from here. Or if you have, like if you, let's say, add a new sheets here, like that. Now we have 4 sheets, and let's come for the first sheet here. Now, if you would like to give for each sheet a revision mark from edit sheet, here you can define the revision of this one as revision 0, but the second one, let's make it as a revision 1. As you can figure, it's not defined yet. So from here, you can insert one of those values, or you can make a custom property called the revision number or something like that, like rev number. So you can make a custom property for the revision and import it. But right now, let's use it as the sheet revision number. So it depends on what you need to do. So from edit definition, let's add a revision mark here for let's select from here a drawing or the sheet property. So if you select the sheet property, you will find here the sheet revision. Okay, so from this, one, you can figure that you have some standard properties for the sheet property, like initial view scale. So you can add a scale as a parameter on the title block here, the sheet number and the sheet revision and sheet size. Here, let's add a sheet revision and let's include it here. So, and click on yes. Now we have the sheet revision. You can figure that it's a long text, but it's a parameter, not a text. When you click save and finish, you will get the value of this parameter. When you come to the next sheet, as discussed, we have 4 sheets. So if you come to the next sheet, activate the next sheet, you will find the value will be changed because we defined it here on the edit sheet property as revision 1. So you can, that's another way to define the revision on the title block. Okay, now let's add another attribute, which is the number of sheets inside the drawing. So let's modify the title block. So from edit definition, let's add another attribute here, which is sheet number. So it's sheet number, like that. And from the sheet number, let's add the, if you open the sheet properties, you will find here the sheet number. That means here, if you include it, that will give you the value of that sheet number inside the sheets. Like here, after importing this one, let's change the text alignment, make it center, okay, like that, and make that one aligned horizontal with that point to define the offset from here to there as 2 millimeters. And when you click finish, that sheet, the first sheet is takes number 1, the second sheet takes number 2, the third sheet takes number 3. So here, that's the number of sheet inside this drawing. So we need to add another attribute, which is sheet number 1 bear the number of sheets. So how to make that? We need to add another parameter here, which is the number of sheets. So if we modify this definition, and here, if we open the here, that's the number of the sheet number, but we need the total number of sheets. So from the drawing properties, you can get the number of sheets. Here we have all the number of sheets, so we can make backslash here, and from drawing property, here we have the number of sheets, so we can insert that here. So we have number 1 bear 4 or 2 bear 4 or like that. So if we click finish, now you have a long text here, but as discussed, those are parameters, not values. So when you click save and come back, now the first sheet will be sheet number of 1 of 4, the second one will be 2 of 4, third one will be 3 of 4, and the last one will be 4 of 4, like that. So by that way, you can define the sheet number. Now let's modify or complete editing on this title block. So let's decrease this spacing, make it 25. Sorry, let's make it 35. Okay, I think it's okay. Or let's make it 40. Now let's add a drawing number, and let's make it in 2 separate texts. So drawing number, okay, and let's make let's go to the next line to add a new text here. And now we need to make a new custom property like drawing number. Okay, and let's make this one as SE CAD. WG 001, for example. So that's the drawing number. Now we have the drawing number will appear here. If we click on OK, now we have a new custom property. So from here, if you select the custom property and select the here, you will find a new parameter appears there, which is drawing number. So we can insert that one. Let's change the size of the text to 0.5. Now let's click on OK. Now we have this text appear like that. Now let's modify the location here as 2 millimeters from both sides. Now when you click on finish, you can figure that the drawing number attribute will appear like that. The same thing we can do it with the project, let's say the location of the project, the manufacturer, all of that we can make it as attributes. Now we have a sheet for the includes our own border and title block. Anytime you would like to remove this title block, you can delete it from here, like delete, and the title block you can delete it. Now the sheet is empty. Anytime you would like to insert your border, just from here, select insert and insert to insert your border and the title block to your drawing. Okay, now we would like to discuss another border property. So let's delete it from here. And from edit, let's add a new property, like let's make that one, and let's divide it like that. Find the dimension from here to there as 15, for example. And now let's add a text like date, for example, date. Okay, or rev date. And from here, let's add one other attribute, which is promoted entry. Okay, so let's add the text for date first separately. Rev date. Okay, and click on change the size 2.5. Okay, and we need to rotate it a little bit, so we can move it and rotate this text, or you can rotate it from the data entry form for the text. Here we have rev date. Let's add another text here and make this attribute as promoted entry. So you can define that as date. Okay, so you can figure that you have date here, and that one we will modify it as a promoted entry. Okay, as a date. So by that way. Okay, when you click, okay, you will get. Let's change. Let's keep the size, no problem, and rotate that one 90 degrees like that, and move it down here. And let's add another text like revised by, okay, size 2.5, and you can rotate it from here like that. So you will get a text rotated by that way. So we need to rotate it on the other side. So from here, let's rotate it on the other side, so it will be like that, revised by, and let's create a new sketch as a promoted entry as revised by, and change the size to 0.5 and make it rotated that way. Now we have that one. When you click save and try to import this title block, now this drawing without any title block, if you try to insert this one, you will get this form. So you can define the values during importing. So here you can figure that we have a date and revision by. So you can insert the date like that and revised by. When you click OK, you can figure that you import those values, which is they are defined here. So if you would like to modify it anytime, you can figure that you have a filled text. So from edit filled text, you can figure that you have a promoted text. You can modify it from here. The other attributes, you can modify them from another places. Like here, you have some custom properties like those, and some other properties like the revision number. It's related to the sheet revision number. So any time you would like, those are some different types of attributes or parameters you can import them. Let's discuss another type of parameters that you can insert it to your drawing. Those parameters are related to the 3D model, which is, let's say this, or the English spanner, for example. Here, if we open the English spanner here from the project, you can figure that the part name, and you can add a description here for this part. You can add some other properties as discussed. You can add some custom properties for this simply. But for this one, that's the part number. Okay, we can make it as a description of this part. Okay, English spanner, and click save. Now we need to add a new attribute or a new parameter here, which indicates the scale of the view and indicates the drawing or the assembly description. Okay, so when you import a view, automatically the scale will appear on the border, which is related to the scale of the main view. So how to do that? So from text, let's add here the assembly name or drawing name, or the part name, simply name here. And here let's click on enter. And from here, let's select properties related to the model. So here, that's the 3D model. And now we will import a parameter related to the 3D model, which is the description. So now that's the description, which we change it to English spanner. It will be reflected here. To import it, just click on that button. Now those we will make them centered on the text, and now we have that text here centered, so we can move it and define the offset from top. Let's make it meters, and from here the length of that is 105, so 105.2. Okay, and now we need to add a scale. So from here we could make a new part like this, if you would like to make something like that, and make a scale. Okay, so the scale will be here again for the drawing, let's say the drawing properties, and no, the sheet drawing properties. Okay, and from here let's add the initial view scale. So when you add the initial view scale, you can figure that you can add the scale of this part, the drawing here inside the drawing. So let's add this one here, and this value is 2 millimeters. Increase that one as 30 millimeters. Okay, and make this align to the center line of this one. And when you click finish, you can figure that the second line of the assembly, let's come back again here. You have a second line which includes the description and the scale. Yeah, if you click finish and save, the values will be empty here for the assembly name and the scale. The values will be empty until you import an assembly. Okay, let's check that. Let's save this drawing as GA drawing. Okay, you can figure that no values here, but when you try to add an assembly, and we will discuss the steps of adding views from here. Let's add this scale and make the scale 1:1. Okay, so we have the this scale and make it as elevation. That, and click on OK. Automatically, you will get the value of the description, which is in English spanner, and the scale of the drawing will appear as 1:1. Try to change the description of the English spanner. Let's make it fixed jaw, for example, like that. We try to change it. When you come back to the drawing, automatically you can figure that the parameter value or the description of this assembly now change it. Let's get it back to English. If you write it in caps, all caps lock letter, it will appear on with the same value. So Here we have the assembly name and the scale of the drawing will appear like that. Now, if you have your own title block on another drawing and you would like to copy it to this drawing, what can you do to do that? Okay, now let's open one of drawings here. So let's open this drawing. It's for another project. Okay, to show you how you can take a copy from border and the title block from another drawing. Here we have this drawing, which include 145 sheets. So if you take a look here, we have 140 sheets inside this drawing, and we have a title block and border, and we would like to take a copy from them. Here, let's take a copy from this border. So let's take a copy from the title block from references. Again, here as discussed at the top, you will find drawing references or resources. So when you open the resources, you will find the borders and title blocks. So from here, let's take a copy from CAD Solution border. So let's take a copy and come back to our drawing. And for the title blocks, let's paste this title block. Now we have a new title block here. For, let's say, for sheet number 4, let's define those values or accept them empty here. Sorry. Autodesk Inventor crashed because the other drawing, which is for SB06, is opened from another project. Okay. Let's wait that, and from open, let's open our drawing from here. Okay, now we have this drawing, and to add a new drawing, let's open the other drawing from here. Let's go to SP06 and open this drawing. Let's take a copy from the title block. So let's take a copy from here, and from there, let's paste it. Okay, and the same for the title block, for border and title block. So let's take a copy, and for the border, let's add those borders here, and from there, let's close this one. Now we have two new borders and title blocks here. Let's save this drawing, and for the first sheet here, let's delete the title block and delete the border. Now the first sheet is empty. If you take a look to the other sheets, let's make a date 3 and division any values right now. So the second sheet here include a border and title block, but the first sheet not include anything. Now, if you would like to import this title block, so you can modify it. So from edit, let's remove this line and click finish. Now we have this title block here, which include those texts here, and you have a new border, so you can insert it here. So you have this title block. Okay, so those modification you can do it importing different title block and border inside each sheet, and that way to copy a border and title block from another drawing to the current drawing. Let's insert those values, and here by. So now we have this those values here. Okay, now if we come back to so we discuss here the how to deal with the properties, and there are some other properties like sheet metal properties, like the default settings that we discussed, like the sheet metal blade thickness, the radius of the fillet. All of those values will appear on the sheet metal properties. Physical properties, you can add the weight or area, and let's add one of those values here. So from let's go back to the let's delete those new sheets and modify this one, and let's add a weight here, or the mass of this part. So from here, let's add the mass of the assembly. let's define the height of this cell as 10 millimeters, and here let's make it 40 and add a new text like weight. Okay, and from here let's select the physical properties of the model. Okay, so it's related to the model, and from here you can select one of those: area, density, and mass. So let's select mass, and here the precision of the value, because it's maybe with you can select the number after comma. So let's make it with the precision 0.2, and from here you can insert the value and make this value in kilograms. Okay, now when you click on OK, you will get the value of the weight like that. Let's change the size of the text a little bit. Let's make it 2.5, make it align to the center, and now let's make it align to the center like that. Define the offset from that line with 1 millimeter, for example, and click on sorry. Okay. If we click finish, now if we add a view, which is the view of the English spanner here, we will get this one like that. Make it elevation, and change the scale to 1:1. And if you would like to, we will discuss that later, but right now after adding it, you can figure that the weight appears here as not applicable because we need to update the weight here. So let's open this assembly, and from the physical properties, let's update the weight. So from the eye properties, open the physical properties and update the weight and get the correct weight here. When you come back to the drawing, the weight of the assembly will appear here. So we need to remove the kilogram at the end here. So from edit, let's remove this one because the mass itself includes the unit. Click save and change. This one like that, and click on save. Now we have the weight of this part appear on the drawing like that. And for the this one, if we open it, for the description, because the drawing is crashed and without saving, so let's define the description here as English. That when you click close and come back here to the drawing, so the assembly name will appear here and the scale, the weight. So we deal with different parameters and include them to the drawing. And now let's go to the next step, which is learning how to deal with the views, how we can import a view to drawing, and how we can modify, make a projection for this view, make a section, adding dimensions. But step by step, let's start with the base view, how to import a base view to a drawing. Here, let's delete this base view from here, and from place views, you can figure that you have a button here for the base view. If you click on this button, you will get this form, which will give you the ability to select an assembly. So if we close this assembly, let's save it first. Here, if you open this base view, okay, you can select the assembly from here. So from open, you can go and select one of those parts, for example, or select the final assembly. So from here, we can select this assembly like that. You can move it any place in your drawing. When the move arrows appear on the drawing area, that means you can move that one. And if you select one of those corners, you can increase the size of the scale, or you can take a look from another size, like the front view or side view or back view. You can take a look from the top view. You can make a look from the isometric view. So the view, you can control it from this cube, which is the view cube here, appears here. So you can control the views that you would like to import it in your drawing. Okay. Okay. Now from here, you can define the detail of view, the master view, or here, and we will discuss that later. and from here you can make the change the view label like elevation view like that, and you can make it appear on the drawing. So from here you can make this text or the label of the view appear, and from here you can make a modification for the title, like adding a scale for this drawing, so we can move it on another line. So here, as you can see, if you have a gray color behind this text, that means it's a parameter. Okay, so that's the view name. It will appear here, and the scale of the view will appear on the second line. As mentioned here, for that you can add other properties. So from the view label property, you can add one of those labels like view name or scale or part sheet name or part sheet index. Some other properties here can appear, but let's keep that one as a scale. And from here you can add text as a scale like that, and the value of scale will appear like that on the drawing. Now if we click on that value and it changes the size of this view to 1:1, okay, you can move this view before during importing, or if you click on OK like that, after importing you can move it to the right place as you would like. Now you can figure the label of this view appears at the top. You can move it by selecting it and move it anywhere. Again, you can select it like that, and you will figure that a new arrow label will appear, including a move option. So you can move it like that, select it and move it for the right place that you would like to do. Okay, here that's the first way to the way to import a view. Okay, and from here you will find some other options, like here the hidden lines will appear. So the first option for styles, you can add the hidden lines to your view, so it will appear on the drawing. As you can see, the hidden lines will appear here. But if you would like to make it with visible lines only, no hidden lines, you can select the second option, okay, which is visible lines only. So you can figure here no hidden lines on this view. And if you would like to include the origin color or the shading colors, you can make it with hidden lines and shaded, or without hidden lines and shading. And by that way, you can include the color to your drawing, or the shading to your drawing. Now let's remove the shading color from here and click on OK. Okay, now as you can see, we have a thread on the model, but it's not appear on this view. How we can make the thread appear on the drawing? Here from the display options, you have some options here for the interference edges, threaded edges, or tangent edges. So for example, if you activate the threaded edges and tangent edges, you can get the threaded feature here on the part like that, and you can detect that the size of this thread is not correct, because here, as you can see, the value here we defined it as 27. So the inside value, it will be like that. So we need to define the diameter of this one, looks like that one. So if we come back to the 3D model, if we open the 3D model here and open this one, we have a thread here. So when you come back to the sketch here and modify the value here, you can modify the inside value here so that's before making a thread. So you can control this value to get the correct value of the thread to suit the configuration of the thread. You can make a half section here. Let's take a half section like that. Okay, so you can figure that the 25 or 24 diameter need to be changed a little bit to suit that one. So if we open this value, this part, sorry, and measure the value here, let's inspect this one, which is 21. So we can change the thread value here. Let's make it as, sorry, let's make it 31.2, for example, and Click finish. Now we have a thread at this area. Now if we come back to this English spanner, you can figure that the thread here and there, they are loaded on each other. Now if we come back to the drawing to update that, you can figure that the thread now is okay. Now let's discuss some other options for the creating the drawing, how to make a new project from this part. Okay, sorry. Okay, let's update this simply. And now let's create another project from this part. So how to generate a new project? So by using a project button, you can add other views. So from here, if you select a project, you can add a side view like that, back view, top view, or bottom view. So you can get a view like this. Okay. So it's easy to generate and calculate the hidden lines, the visible lines, all of that automatically. No need to assume any lines or something like that, because when you create the 3D model, and that's the powerful point for the CAD software. When you make the 3D model, no need to check or guess which line is visible or which line is hidden. So it's automatically calculated by the CAD software. By the same way, you can add those views during importing the main view. For example, here, let's select the assembly, which is, or this part, for example. We have this part here, make the scale 1:1. During importing the assembly, you can add the other views like that. Okay, the isometric view. Okay, those three views are the same, no problem. So you can delete that one and delete that one. So you have the top and the bottom plane and the isometric view. So let's move it a little bit from here and click on OK. Now you have, during importing the main view, you can import the other views to your drawing. So let's remove those. Now let's add a side view and top view, and you can name those views by double clicking on that view, for example, and modify this value as side view. From here, you can import the title of this one, and you can figure that as default you will get the scale. Now no need for the scale because it's the same scale for the top view. So we can remove the scale from here and click on OK. Now the side view will appear at the top. You can move it at the bottom like that. And we will learn how to control the default appearance for the label. If you would like to make it at top or bottom, how to control that from these styles. Okay, now let's add another label for that view, which is top view, and make it appear. Let's remove the scale. So from edit, let's remove the scale and click on OK. Now we have a label for this view as a top view. Okay, now we know how to add a projection for this part. Like if you would like to add a 3D model like that. So the 3D model, you can move it like that and make it with a shading color. So from here, we can change the color and make it ISO, for example, make it appear and the scale from here. So it's up to you to add a label for the 3D model, add a color or not. So you will get the 3D view like that, and that one have a label like this. Now let's save this drawing. Okay. And now let's learn how to add auxiliary view. The auxiliary view, if you take a look here for this slide, if you would like, you have a aligned line, for example, and you would like to use this line to make a view along this inclined line, like this. If you select this one and select this aligned line like that, you can make a view along this line. By that way, sometimes the configuration of the part or the assembly makes you select this option to get a correct view for the part. In our case, it's not appear here, but if you sometimes you may need to make an auxiliary projected view by using a tilted line or something like that. So by that way, you can make an auxiliary view by that way. One more option, which is making a section. So if you would like to make a section for this view, so from section, let's select the view first. So the first thing you will do, which is selecting section option. After that, select the view. Here you can select the line that you would like to make a section from it. So you can figure that you now snapped to the center line of the arrow snap to the center line of the this line. So you can make a section along this part like that. And when you click on continue, right click and select to continue, you can make a section on the right hand side or on the left hand side. So let's make that section on the right hand side by that way. You can select the section option as a distance. So you can make it without a full distance or make it as a distance to define it at the half. Change the scales, change the label. So from here, let's modify it as section. Let's remove this scale and make it section A to A. So from here, section A, okay, and click OK. Now we have this view. You can make it as an inclined slice. So we will discuss those options right now. So from here, make a section like that, and you can figure that you will get a hatch along the part. By that way, if you select the options of this one, which is edit selection option, from here, if you would like to make it inclined slice, for some features like the forged hub, we will make a sample for a forged hub. This option will be important for us to make a slice cut, make it along the part in two directions, and it could be appear here if we take a section like that. So from here, let's take a section along this part, but on the center here, let's make another perpendicular section. So from here, you can make another section like that, but in that time, we will make it inclined slice. So when you, let's modify the section property from here. Let's edit and make it aligned like that. You can figure that the sketch, the section itself comes, make a projection for this one and make a projection for that line, not along the part. It will appear like that by using the aligned option. So from here, the aligned option give you the ability to make a view like that. If you make it projected like that, you will get the section by that way. Okay, let's delete this section. Now we learn how to make a section, and if you would like again to make it with hidden lines, visible lines, or shaded, if you would like to include the threaded or aligned faces or something like that, you can do it from those options. Now, if you would like to make a detail, like a detail for this piece here, and or this one here, make it with the large detail, you can do that by using the detail option. So from here, if we select this view, first thing you can select the view. After that, select the areas that you would like to make a detail for it. So let's take this area out here with a large scale. Define this the scale view, and from here, if you select this option, which is set cut edge, you can get the sketch with that cut out as a rough cut out surface like that, or you can make a modification on that by make it with a smooth cut out shape. So the cut will be with the smooth edges. So again, that's the rough cut. And if you would like to make it smooth, from options, select the cut view from here and select smooth cut shape. And you can change that shape as a full detail boundary. So here from the full detail boundary, you can make a connect line like that. And the detail boundary itself, you can change the style of this line. And we will discuss how to control the styles on next minutes, inshallah, after discussing the options of detailing. Here we have another one, which is overlay detail. We can use this option of overlay in case if you have a mechanism. This mechanism includes different locations, and you would like to define different locations on the same drawing. So you have a main view and another view includes on the same view include another location for this part. You can do that on the assembly itself from representations here. From the representations, you can add a different views. Like here, if you would like to include another view like front view or ISO view, for example, let's add an ISO view. So here, ISO view, and this ISO view will make the assembly appears from that side. So that's the ISO view, and you can make another level of detail, and this level of detail you can make it without fixed jaw. So here without without movable. So in this level of detail, you can make this part disabled or suppressed, so we can suppress this part. So the assembly will appear without this part. And when you come back to the drawing, as discussed here, you will find some options for that, like the views and the master view. So you can make this view appears without the movable show. So you can change the view as the master view or the default view by that way. And for the assembly itself here, as discussed, for the position, you can define the new position, which defining another position for the jaw. So let's make this position appear here, and inside this position we can define another value for modify and override. So we can make it 30 millimeters. So for the master view, you can figure that we have the first position at 20 millimeters, and on the other position you have a position at 30 millimeters. Okay, so from here you can select the master position view, and here you have the position 1. So we can make it like that with that position, and by using the over view, you can make it with master, or let's make it with a position 1. Sorry, let's make it with the master view. Sorry. You can represent this one as a master view, make a link like that. So you can figure that you can indicate 2 locations on the same drawing by using that view, which is overlay. Okay, it's maybe needed on the mechanisms, but here it's not needed actually. But we can do that by using the overlay, by defining a new locations inside, or different locations inside the that part, so you can deal with it on the drawing. So let's come back here and make the position to master view and make everything come back and delete this. Okay. Now we deal with how to make a detail, how to make a section, auxiliary, projected view, and projected view. Now let's discuss some other features like adding a draft view. Here, for example, if you would like to add a view, but this view without using a 3D model. Okay. For example, you would like to add a detail for, let's say, blade to blade. Make a new view, and that view you need to indicate a blade welded to another blade like that without making a 3D model. So you can define the height is 15, and here the thickness is meters. The length here, let's make it 50, and make a hatch for this one like that. Another hatch for this one with a different. Sorry, select one of them first, like that, and accept. After that, make a new hatch with a different value, like that. And now you have a view. This view is not a 3D based on a 3D view. It's just a draft view. So you can move it, give it a name like that, make this name appear, give it a scale. All of that you can add it to this draft view. Align like that, make it appear. So you have a view like that. It's just a sketch, not based on a 3D model. And you can add dimensions to this one like that. Okay, all of that you can do it to the sketch or draft sketch. Now let's delete this one. And from here, let's add a break view. So to know how we can use this break view, let's use another sketch and add part number 1. So from here, let's select the fixed jaw and increase the scale to, let's say, 4 to 1. Okay, so you can figure that the scale of this one is increased. Let's make it 3 to 1 instead of 2. Okay, it's still outside the drawing, but I would like to show you something for the break view. Now we need to make a scale like that. So to use the break view, if you have a part with a lens and you would like to make a break along it, so you can select this area like that and make a break along the lens by that way. And for the properties of that one, you can define as a break style with a rectangular style or structural style. You can change or control the size and the gap of this one. Let's make 15 and the sample like that, so you can control the gap size. So by that way, you can make a break through the part. If you have a long part with a long length, you can make a break with the length. And if you try to measure the length, by the way, when you try to measure the length, you will get the correct length. Okay, not that actual length on the drawing. It's the actual length on the 3D model. Okay. Now let's come back to the 3D model again here and save this drawing. Now let's discuss how to make a breakout for the model. The breakout gives you the ability to make a section for a defined area. For example, here at this area, we need to make a section here to show the thread with this area. So from here, let's get a spline and make an area here. Let's close this area. And this area, we will make a cut on that area through the 3D model. So by using breakout, so first you should have a sketch. Okay, you should have a sketch. After that, you can use the break layout automatically and select the view. Here, the sketch will be selected automatically. Now, if you select depth, you can define the depth from view or from sketch. And if you select one of those edges at the center point and click on OK, now you can figure that you make a section at that area only, not all the model. Okay, so break view gives you the ability to make a break view on the view that you have to a defined depth. Again, for this break view, you can define the depth of this one from. So if we make this one as a 10 millimeters, you can figure that we make the depth here. That's the center. So if we make a line here with the center, so we select the center point at the middle. So if you make a section with a depth of 10 millimeters, so that means you will move this plan back here with 10 millimeters. So you will get this sketch like that. If we make it again, let's say 2 millimeters only, you will get this one. So you can control the depth of this view. Let's make it 0 to make it at the center line. Okay, now let's come to the next feature, which is slice. So this one you can use it in case if you would like to make a different sections on a 3D model. So you will need to have a 3D projection view. So let's select this one, for example, this view, and make a 3D projected view like that. Create that one, and you can figure that you have a break view inside this part. Now, if you try to make a section along this one, or let's make it along the here. So you will need to make a different line. So you will get different sections along this part like that. And click finish. Now when you try to make a slice, select the 3D model and select the sketch. Okay, now when you make a slice part, because we have here a break view, let's delete the break view. Okay, and again, where is the slice sketch? We have, let's delete this and let's delete this one. Okay, and make new sketch here. Sorry, let's make a line like this, another line here. And be sure that the lines are vertical. Okay, those are vertical. So from here we have this one, and from slice, let's select the 3D view and select the lines and select slice all parts. Now you will get a 3D model with different sections along the lines that you select as a 3D slice feature along the part. Okay. The second modify feature, which is group. For example, if you would like to make a group for this view, so you need to select the view and select this area only. Okay, so you can make a group for the view to make this area only the visible area on. All of those features can be controlled like that. That's the group. It will stored on the tree of the drawing, so you can come back anytime and modify it. Here for this view, for example, that's the main view on the drawing, which is the isometric view. So if you double click on it, you will get this form. You can modify the scale, the title of the drawing. You can make many different things here. And for the other views, if you would like to get this view, when you select it and right click on this view, you will find in browser. This will give you the ability to catch the view on the drawing. It will appear on the right side here. So if you would like to modify on it, you can modify, define the sketch, the group, all things you will find it here, so you can log in and modify it again if you in case of needing to modify it. Okay. Now let's check other modifying options like aligned. Here, when you add this view, you can figure that you cannot move it up or down. It's just right or left because it's aligned horizontally with that view. So to give you an access to move this part up and down, you will need to break the link between those views. So from here, if you right click on this view and open the shortcut menu, you will find from aligned the break the alignment. So here, when you select it, you can figure that you can move it up and down. So this view will be movable, so you can change the location of this view. To make it aligned again with the previous view, just select it, and from aligned, select horizontal aligned, or from the shortcut menu, select aligned and horizontal, and select this view. Again, this view will be aligned in horizontal position with the main view of the drawing. Okay, now let's delete this group here that we did. And now let's, from here you can insert a new sketch and create a new sketch, new sheet, sorry. Like here we have 4 sheets. If you would like to add a new sheet, just modify the date here. It's and revise by like that. Click OK. Now you will get sheet number 5 with the new information here. Let's come back to the main drawing. Now let's go to the annotation and how we can add dimensions to this sketch. Now let's add some dimensions and how we can control the dimension properties from the style tab. Okay, before going to add dimensions, let's discuss how to change the style of text, style of dimensions, balance, texts. All of that we can control it from the Manage tab and Style Editor. So from here, now after discussing the draft and the breakout and the slice view, how to make alignment, sketch, and create a new sheet, we need to discuss the dimensions, but before that, we need to discuss the styles editor. So from here, from Manage tab, we will need to open the style editor. Okay. And from the style editor, we will get this list, which includes the default standard for the ISO drawing. And from here, you can figure that each field of those, you will find some properties for it, and you can modify it. For balance, for example, you have the ability to change the style of balance. For dimensions, you will find different styles, and they use the style which is default to ISO. You can modify the units, decimal mark from dot or comma, the precision of text. If you would like to trailing the precision number, the alternative unit, if you have another alternative unit you would like to include it inside the dimension. All of that, inshallah, we will discuss it. But here on the tree, I would like to say, here inside this tree on the left-hand side, you will find all styles and all options, like controlling labels, tables, surface leaders, texts, welding style. All of that you will find it on this style editor, and by selecting the required one, you can modify the properties of this style. Here from the standard ISO, for example, you can figure that the units of dimension in millimeter, and you can change the decimal mark to period. You can select the default line thickness from here. From the views, you can select it, the default view for the first angle. You can select this option or third angle, and I think all of us knows the difference between first angle and third angle. Let's check that for the third angle. For example, if we select it and try to get a view for project view for this one, here you will get actually on two second view, you will get the front side here. But by using the third view, you will get the back side. That's the back side, as you make a look from here, not from the front. Okay, so it's a reverse direction of the second view. So let's come back to styles again. Okay, and from here, let's change it again to first angle, not third angle. Okay, so you can select the shape of hatching around the thread if you have a thread. Make the thread view from top view. Some visibility of lines and datums, and here you will find all layers that you have. And for hatching, you can insert another library. So here all the library of Autodesk Inventor for hatching. So you can select, for example, find the some other references for hatching and include it and load it to your model to use it as a reference. Here for the dimensions, what we would like to discuss. So let's save this. And for the views, here let's define the units. So let's make it unit in millimeter. And for the precision, you can increase the precision. And from here, you can make a trailing for the precision. That means to make this point clear, here if we keep the trailing 0 appears and add a dimension. So from here, let's remove this view. And from annotation, let's select the dimension. So from here, let's add a dimension between this, which defining the opening. So here you have the a dimension defining the that value, and here you have the precision with 2 numbers after comma. And to make a trailing for this value, if you have a value in those boxes, they will appear. If not, they will disappear. So to make a trailing for that, from here, if you open the style, and from here, if we open the dimensions again, if you remove the trailing 0, if you click on save, now here you will get the value of that one. If we come back to the model here and define this value with 20.11, okay, we change the value of this 20.11. So if you come back again here, automatically a trailing for making a tracking for the numbers here after the comma, and if they have a value, they will appear. If they equal 0, they will not appear. So that's the meaning of trailing 0 from the style editor. Again, let's open the style editor again, and here let's make the same thing with the angle. And for the alternative unit, if you would like to add an alternative unit here, so let's add, for example, a foot value, and from here let's select period and select the fraction value. So let's select it instead of decimal, let's make it as a fraction like that, and the precision, let's make it 1/32, and that's the fraction text scale. So let's make it 50 instead of 70. Okay, and for here, for the dimensions with a length dimension, we would like to include the both dimensions. So the value will appear in millimeter, after that between brackets the dimension in foot. So if you click on save, now it will appear like that here. Okay, so if we measure something else, like the total height from here to there, for example, from here to there, it will appear like that in millimeter and foot and inch, like that. So now let's edit this value to and come back this one to make this value like this. Now you can figure that if you would like to make let's wait until opening this one. For the alternative unit, here for that value, the lead 0. Here you can figure that if we take a print screen and take a look at this. Here we discuss the trailing 0 for the second part. But what about leading 0? If the first value, which is in foot dimension, equals 0. So if it's the main value equals 0, we need to make it not appear. Here, if you take a look to the image here, the main value here, which is in foot, equals 0. So we need to remove it. We don't need to make to write the value in that type. Let's make it appear on inches directly. No need to foot here. So from here, if you make it lead 0 and click on save, automatically you can figure that the value of the lead value, if it's equal 0, it will not appear. The fraction only will appear. Okay, so that's a way to define the dimension by using leading 0 or trailing 0 for the second part of, or the fraction part, or the value after comma. Okay, so that's for the alternative value. Different styles you can use it to make the dimension appear, and the same for hole. If you would like to make any holes appears in the same style, so you can use that style. The same for chamfer, you can make a style for chamfer. The same for a flat pattern if you have a flat pattern, and for punching you can use the same. So here that's the way to define the alternative material. And for the main unit, now let's define the dimension of the arrow text size and the arrow size. All of that we can define all of that from this view, which is display view for the arrow. So from here, you can select the layer of those arrows if you would like to change the thickness of arrow or color, but let's keep everything based on the layer no need to change it. The arrow shape, so you can change the arrow style. You can make it with a closed or blank. You can make it filled. You can select the suitable arrow shape from here. After that, define the size, height, and size and height. Okay, and in case of using a chain type dimension, and we will discuss the chain type, you can select the suitable arrow for chain type dimension. And here, based on this sketch, which defining the space between the extension line, which is dimension B, which is the origin offset, you can define the offset between the edge of the dimension from the end. So let's make it 1 millimeter, and for this one, which is dimension A, let's make it 1. And the gap of the text between the dimension and line, let's make it 1.5. And dimension D between the two vertical dimensions. So you can control those values like that. So when we click on save, you can figure that you will get a gap here, okay, and the length of this one will appear like that, and the spacing between the dimension and the line will be modified. So from that tab, you can control the size of the arrows. So from display, you can control the size of the arrow dimensions and the gaps between the dimensions. Now let's make this one. Let's decrease the value of C. Let's make it 1. And for the text, that's the text properties. So from here, you can select one of the standard texts here for the table, for the text, to modify the size of the text and the text font. Everything related to the text you can modify from here. For the primary text or for the tolerance text, if you would like to add a tolerance unit, so you can control the tolerance unit text dimension. Now to modify the text height from here, if you make an edit to this one, you will get here the standard texts, which they are included. Automatically, you will move from the dimensions to the text. Okay, so here you have two standard texts here, and we would like to create a new one. So from node text or label text. So from node text, let's create a new style. So from here, let's click a new and create as ISO dimension text. Okay, so that's a new text, and for that text, we will define the size. So from here, let's select the font size for font format, and from here, let's define the height. Let's make it bold, for example, or equal if you would like to add a comment, and the spacing if you have more than one line. After that, when you let's save this, so let's save this one, and when you come back to dimensions, you will find a new text here appear, which is ISO dimension. So you can select the ISO dimension and it will automatically reflect it here. For the tolerance, you can select one of those, or you can, for example, if you can select for the node and or the use the same standard and change the scale of the reference. You can add a prefix text or suffix text. But right now, let's check the style of the dimension. You can figure that the size of the dimension and font now changed. Now let's make it come back again to Tahoma and change the font size to 3.5. So from here, let's go back to text and edit the ISO file. So select from here Tahoma and change the text to 4 millimeters height. You can make a stretch for that one. And now let's save this one. Okay, automatically you can figure that it's changed. Now let's remove the bold text. So from here, let's come back and remove the bold and click save. Now you can figure that you can change the font of the dimension. Let's come back again to the dimensions here. You can control the visibility of the dimension. the orientation, and for a long dimension like that, you can make the text over parallel to the line, and you can make it in line, so it will be inside the line. So if we select this option here, if you come back here, so if you create a new line, so from here, let's add a new line from here to there, and let's come back to the manage. Sorry. Let's wait until opening this form. Here, so from text, let's select this one, and for aligned text, let's make it like that, and for vertical, the same. So that's for horizontal, and that's for aligned, and that's for vertical. So let's make all of them in line. And if you have more than one line, you can make it part of it over the line and part of it below the line. If you have more than one line, okay. So let's save this. Okay, so you can figure for vertical dimensions, it will appear like that. For aligned dimension, like that one, it will be on a line, and for the horizontal line, it will be like that. Now let's check the other options for the dimension. Here for the tolerance, okay, you can add the default tolerance as asymmetric, for example, add a value for the upper and lower value, or make them with a limit fit, or with a deviation, so you have upper and the lower limit. You have to control the leading zero or trailing zero, as we discussed, or that the style, make them on parallel on the line, or up or down, so you can control the configuration of the tolerance, and the option of the dimensions, how to make a line, if you have a circle or angle or line, how the arrow shape will appear from outside or inside. If you have an angle, the arrows will be inside or to outside. The different options that you can make with the dimensions. Now for the notes for thread or holes, you will find a default option for that, and you can make a modification to, if you would like to add the whole dimension for the thread, or you would like to add the depth or designation, all of that you can add it for the text of the whole right here. The same for the if you have a circle, you can control the appearance of this one and the text up or down. If you have a thread hole, you can modify it like that. For the chamfer, the same for the chamfer, you can change the default values for distance and angle. You can write it in different ways, like two distances, or distance with angle, or two distances. So you can define the designation of or the format of the thread. The same for bending angle. If you would like to modify the diameter of fillet and the angle of fillet and the radius of the fillet, the same for punch. So you can change the definition of each one of those by that way. Here for the dimensions, as we discussed, here you can make changes for the dimensions. Now let's discuss the layers. Here, if you select the layers, you will find different layers, pre-built layers inside the Autodesk Inventor drawing. Like for example, here for the dimension layer, if you select it from here, it will be activated. If you would like to make it visible or invisible, you can control it from here. The color of dimension, you can control it from here. So if you would like to change the color of the dimension, you can change it from here. The thickness of the line during printing and preview, you can control it from here. For example, for hidden lines, if you would like to change the hidden lines color to make it in gray, so let's make it with a gray color, okay, and change the hidden lines to make it 10 millimeters. Change the hatch, so from the hatch, let's change the hatch color. Let's make it, let's say, green color like that, and change the thickness of that one. So when you click on save, automatically you can figure that the hatch color come in green, the dimension of the dimension color come in like that, and the hidden lines become in a gray color, not in black color. So by that way you can control the layers of the drawing. So by that way you can control the layers of the drawing. So let's come back here, change the color and the line style itself. For example, here we discuss the cutout, which is the break view. So if we have a break line, you can control the style of the line. So the default here is a continuous line for the break line. So if you would like to make it a chain line, just from here and change the scale of this one. And for the section view, for the section line, the same. This section line, we can change the thickness of this line to 0.4. And when you click save, automatically you will change the thickness of this one and the breakout lines again. So from here, let's open that one again, and may I select something else for the breakout. Sorry. So from here, let's come back and sorry, it's the tail view. So from the tail view, let's make it as a chain. So which is the boundary of a detail. So when you make it like that, automatically you can change the breakout view or the tail view like that. Now, one more thing we could discuss it here on that level of modifying, which is the balance. So from here you can make this. Okay, here we discuss the layers name. So you can create a new layer. You can control the visibility of the layer from here, on, off. Okay, so from here you can make it on or off. The appearance is the color of this layer, and the line type. So you can change the line type, make it a chain or dotted or anything, or you can change another from one. Like in AutoCAD, you can load some other lines. So you will find here some other standard lines. So you can modify the line from here and change the thickness of the line during the printing and the scale of the line. So you can control the scale, and from here you can make this layer printed or not, so it will appear on the print or not, like that. Okay, now from here you can change for the samples of welding. You can find identification of lines, so you can select the suitable style for you. Make it control the scaling factor of the fillet. Change the style. Make it the default option for the fillet at top or bottom. That's default option. And if you would like to include some samples from here, that's the library samples. So you can include the samples from here, or contour samples, packing samples. So directly from this list, you can include the required samples to your standard samples from here. For the section view, you will find different section views. One of them is that view, which is with smooth lines like that, and then you can figure out the difference between them. You can change the arrow shape, the extension, and arrow size, height, and size of the table, of the arrow. For the tables, you can import one of the standard tables to your drawing. Like you can create your own table. Let's create a new table, for example, like rev table. Okay. And this revision table, you can control the title of this one. Okay, and from here you can control the label size and the column header size text. That's for the text, for the title, for the header, and for the data inside the table. Control the gap for the text between the gap and the heading. control the arrangement of the table if you would like to make it start from top to bottom or bottom to top or without any heading. Control the spacing between text inside the table. And from here you can define the table setting. So from here, let's add a column. So the first column, let's modify it. So from here, let's add. So let's modify the column from here. So you can control the name of that one, which is rev number. Okay, and define the width of this one to make it 20 millimeters aligned to center. Let's add another column, which is, let's modify this one and make it date, for example, and find the width of this one as 35. Let's add another column, which is, let's say, issued for description, issued for, okay, and the width, let's make it 55, for example, and let's add drawn by or created by. So it's draft man, or let's say prepared. Okay, and the value, let's make it 25, and another column for here for the checked by, and another one approved, like that, approved. Okay. Now you have a column for each one of those. So when you click save, now if you try to add a general column from here, you can select directly the revision table and define the number of columns and click on save. So click OK. Now we have that column, and if you would like to, sorry, I think we didn't save it, sorry. We didn't save this information. So from table, if we come back to column, okay, it's activated, okay, and here that's we have 1, 2, 3, 4, 5, 6. So we have 6 columns. So let's remove this, and from table. By the way, you can add a revision table directly from here, or if you have a general table, you can select that, and from revision table you can, okay, sorry, it's, you can select one of those tables. Okay, I will check that here. Okay. Okay. It's for the revision table. I make the modification on another one, sorry. So let's come back to the style editor. Here's the modification that I did. I make it over the table, the standard table, not the revision table. If you take a look for the revision table, it's still at the default, but I made the changes to the ISO table. So you can figure that the ISO table, which is the one which includes the modifications, let's delete this one and insert this table again with 3 columns and 5 rows. And from here, let's select table ISO and click on OK. Now we have this revision table here, includes the revision number, date, issued for, and anytime if you would like to add another field or modify the arrangement. So from here, you can edit table layout, and you can figure that you can make it start from bottom to top. So when you click OK, the revision table will start from bottom to top instead of top to bottom. And anytime you can open it and modify the values inside one, like that, for review and approved by or prepared by, like that. So you can fill this table the revision table. And here you will find a standard revision table and revision mark. But let's step by step discuss the style editor options. Let's open the style editor again. And for the revision table, you can control the revision table and create your own revision table. The revision table will include the zone, revision number, comments, and so you can take a copy from this one by make a new one as a copy from this one and modify on it and keep the standard one. The same for the bill of material. You can create your own bill of material style here. For leader text, okay, and for the for balloons or for hauling or for datum lines. For the balloons, you can change the balloon style and balloon size. So from here, for example, you can change the style of the balloon, and for the center mark, you can change the style of the center mark for a circle or for a longitudinal cylinder like that. So you can change or control the styles from here. Now let's delete the dimensions from that view and make a modification for the dimension style. Keep it with one value only for dimension, and we will make a detail view. So from here, let's come back dimension, and let's remove the secondary or the alternative dimension. So let's make it keep the original value only. And from here, let's discuss how to add dimensions. So from annotation, after discussing the styles, how to change your style for dimensions or for hatching or all the drawing. One more thing, sorry, before going to the next step, which is how to export this style to use it in another drawing. So from styles, you can export the standard style from here. So if you select the standard style, and from here you can export this style in style XML format. So you can add the standard style, for example. So that's the standard style, and you can keep it, for example, on the desktop. So anytime you would like to import this style, so it will be saved here. Sorry, you will have this file saved here. So anytime in any other drawing, for example, if we open another drawing, for example, and now let's modify the style of this one. Directly, you can import the saved style to avoid repeating, making the same things again. So from import, directly select standard style. And now if you add a view, for example, let's add this view. Now if you try to measure a dimension, you will get the color of the dimension like that. You will get the length like that. So here we add the we need to modify that on our drawing first, which is a precision. So from here, let's remove it. So from dimensions, let's select the default dimension. And from tolerances, here, let's make it default. Again, not a deviation. So from default, let's save this. Okay, and the same thing you can do it here. So here, by that way, you can export and import the drawing style. And now let's add dimensions and check how we can select between different dimensions. The first type of dimensions, which is general dimension. By using the general dimension, you can add the arc diameter or arc radius. So from here, you can add arc diameter or arc radius like that, or arc length. So you can measure the arc length like that, or angular. Many types of dimension you can do it like that. That's the angle of that arc. So many different options. You can use it with the same origin dimension. You can add dimension like from that line to that line, and the measures the dimension from here to there like that. The same for that one. Add a radius here for that part. That's for the general dimension, and the same for the angle. If you would like to define an angle, or it's already defined it by dimension from here to there, so you can define it like that. Okay. The next type of dimensions, which is baseline, so you will need to define a reference line. So if we define this reference line, you can select a different lines based from this line like that, and right click and continue. Now you can make a reference line. So at one time you can make, so right click and make create. So you can add those lines as a reference line from one edge here. But if you would like to select one of them and delete it, you can do that. If you would like to select one of them and move it, you can do that. But if you would like to make them as a group, let's select them like that and delete them. From here, you can add a baseline as a group. So from here, you can select those lines like that and right click and continue. Now you will get this one. Right click, but after clicking on drawing, right click and click and create. Now you have those files. Now they are as a one group. So if you select one of them and delete, all of those group, all of this group will be deleted. Now for the second type, which is the ordinate. Ordinate type will give you the ability to add a reference point. So for example, here we will add this point as a reference point, and now you can select different levels. This option is very important in pressure vessels and heat exchanger to make a reference point, so you can define the level of this one from a datum point. So here you can define the location of those lines from the datum point like that. By the same way, you can make them as a group. So from here you can select those lines like that and define them as a group. So from here you can define them as a group like that, so they will be referenced by that way. Okay, again, if you would like to add another type of a chain dimension, so this chain dimension will give you the ability to add, to take each line as a reference line for the second line. Like here, you would like to measure the distance from here to there, okay? And if you select this one, the reference line will be the previous line. If you select this one, the previous dimension will be or as a previous line, like that. So if you make continue, so it will be a chain like that. Okay, and you can make them a group in a group by the same way like that. So continue, you can make a chain value and click on continue. And for the small one here, you can move them as a group. So the small one here, you will not be able to change it. So if you would like to delete, you can delete all the group like that. Okay, for the arrange, if you have, for example, have some dimensions like that, they are not arranged with the different levels, and you would like to arrange those dimensions vertically. By selecting them and click on arrange, you can make them arranged vertically with each other like that by using the arrange order. Okay. For the whole feature, if let's take a section on that view. Sorry, but we haven't holes here, so let's make a hole by using the whole feature, or we can use let's say let's add another view from the previous day. We did simply for the bearing bracket. So let's take this one and take it as a copy inside our project. Let's save this drawing. Okay. And let's go to the next sheet. Let's remove this view. Okay. And from here, let's add a base view, but this time let's select the bracket view. So from here, let's select the bearing bracket view. Okay, let's add this view and let's make another views here. So by using the whole feature, so from here, when you select the whole feature, you can add the whole information here and there. So we create a whole, and you can change the definition of this whole. For example, if you would like to add the number of holes, you can do that. So here, that's the quantity. So from here, you can add that by that way. So you can insert the quantity by that way. So we can take the quantity from here. So that's you will write the hole diameter times the quantity of holes. So we insert it from here. So the value will be 516 times let's modify this value, and from here let's remove that one and let's import it again like that. So we have 4 holes here for that one. So by using this option, we can make 4 holes here with the same diameter. The same thing, we can do it with those holes. So we have 3 holes here, and let's make them that defined that way, insert like that. So we have 16 millimeter with deep 26. We have 3 holes. So you can modify this text as like that. So this value will be as a parametric value. Okay, that way to insert, let's say, a hole detail like that. And if we come back to the previous sheet here, if you have a chamfer like this, you can add a chamfer by that way. So the chamfer value, you can add it like that. If you have a bunch on a sheet metal part, you can add it. And you have a bend, you can add, let's check the previous session. We was have sheet metal parts. Let's select this part, for example. Let's take a copy from it inside our project and get a flat pattern for it. So from here, let's add a base view. Okay, and from here, let's select this part, which is the sheet metal part, that one. And let's make it as a flat pattern. So you can insert this part as a flat pattern part. You can increase the scale as 1.5 to 1. 1 to 1. Okay. 3 to 1. Okay, I think this scale is okay. Now we have this part as a flat pattern part. So let's click on OK. Now we have this bended part here. And if you would like to add bending information, like we have a bend here in this line. So the bend information here inform the labor that you have a bending here with 45 degrees and the bend radius equals 0.5 millimeter. So by the same way, you can define the bend in each line here or there like that. So it will be bend down or bend up. On each bending line, you can define the values like that. And if you select from the data point, you can reference it, take it as a reference like that. So you can move this value by that way. Okay, so you can add bend dimensions on that one. Okay, how to add a label or a text to the view. So from here, for example, if you would like to add a text, just by clicking on an empty area on the drawing, you can add a text. Okay. So you can change the text style, font, make it bold, italic, all of that. You can do it with the text. So by that way, you can add a text. Or if you would like to add a label text, like add a notation here for that one. R equal 40, for example. It's not a dimension, but you can add a text here like that. You can add a text annotation by that way. And from here, you can import samples. Okay, so how to deal with these samples? Here we discuss the border, how to create a border, and how to create a title block. But what about the samples, sketch samples? How to create a sketch samples? If you take a look to the sample of today here, let's come back to that sample here. You can figure that we have a surface roughness here, which takes a sample, looks like 2 triangles. So how to make a sample like that and use it? So from here, let's select sketch samples, and from here, let's create define a new sample. So Now we are on the level of detail of sketch sample. Now let's create two rectangles. So from here, let's add a rectangle. So here we have this one. Let's add another one like that. And let's connect those points, make those lines parallel, okay, and make both of them in a horizontal level. Make the size of that line equals that line, and after that, the last thing, let's define the height of that line. So we have that sample. Let's make it as a surface roughness and click like that. So now we have a new sample here for the surface roughness. If you double click on it, you can add this sample in your drawing, and you can import it from the samples here by inserting sketch sample. So you will get a list for the samples that you have. So you can import it, and you can change the scale. So if you make it 0.5 and rotate it with 90 degrees, you will get this sample in that way. So you would like to move it, you can move it like that, and you can add it directly without adding an arrow. So you can move this sample like that and add it by that way. So that's another way to creating a sample. So let's make another sample, for example. So from here, let's create a new sample, and this sample we will make it as, let's say, the north direction. So for example, if you add a north direction, so we can make an arrow like that. Okay, and make those lines equal, and make this point vertically with the half, that one. Let's define the thickness, let's make it millimeters, and the total width here is millimeters. The height, let's make it, let's increase this one a little bit, let's make it 80, and add a hatch for this one. So let's add a hatch as a solid hatch. Now we have another arrow. We have another block. Let's make it arrow. Okay, now you have another sample. So you can use this sample like that as direction of opening or something like that. So by that way, you can create a sample and use it. So if you insert the sample, you will find the two samples that you are using will appear here. Okay, let's change the scale. Sorry, let's make it 1. And change the orientation like that, and remove the lead option, or make the select directly like that. Continue. So we have this one, so you can rotate it like that, or you can define the orientation angle by double clicking on it and define the orientation angle. That if you would like to rotate it on the other side, so it will be 270. So you can move it the other side like that. Okay. Now we discuss the dimension features and the whole features, chamfer, punch, and bend texts, and how to insert samples. Now you have another samples for the weldment samples, surface roughness, and many other features. So let's discuss one of the fillet, end fillet. Like if we have a weld, for example, if we create a new draft here, as we did before, let's generate two lines like that from here to there. Let's click finish. Now if you would like to add a weld sample, so you can select this line and select the configuration of the samples that you would like to import. For example, we need to make a fillet weld with values, let's take 25, and select the corner here. So automatically you can get an option to insert this fillet weld like that. Again, if you would like to make another fillet weld with different values, like make it 20 by 10, directly when you make it like that, you can flip the value. So that one will be 10 and 20 like that, or you can make it with a grooved shape. So you can make it like that. Click apply, so you can get that one, or make it as a grooved value. Click on apply like that. Many different ways to make the fillet weld. So let's delete this one. So you can make a groove like that if you have two straight edges. So different ways to add a groove by that way. Now if we have another, let's delete this view. Let's add another view, and in this view, let's make two rectangles by that way as a top view for the part. Let's center this one like that. And we have a top view and we have a fillet weld. By another way, we need to indicate the fillet weld. So from here, you can use this type of welding to make a stitch weld lines like that. So you can define it on one side, controlling the size of the width of this one, like 4 millimeters. The angle is 90 degrees. Make the arc percentage from the spacing. Define the spacing between the stitch lines like that. Make another lines by that way, and right click and click on apply. Now you have, if you would like to add another sample for the welding, you can use this type of sample. Now to add a fillet weld, for example, here, let's say those are two separate parts, and you would like to make a weld here. So by that way, you can, by selecting a weld, you can select the sample of weld and make a continue to edit the form from here. So you can select the default value. You can flip the direction of the fillet weld. You can figure this triangle direction at up. If you flip it, it will be at down. That's the default. You can make it as a circular weld. Make it filled weld by adding a flag here, or make it a circular weld. If you would like to add another option for welding, you just select the sample from here to there. If it's a groove weld like that, or it's two surfaces, radius surfaces like that, or a groove weld or a fillet weld. So you can select the option, and you can add a top character here to indicate the end of the fillet weld. It's at top or bottom or flushed or faced like that. So you can control the dimension of fillet. You can add values for, if you have, for example, a staggered weld, so you can add the staggered value, length of the staggered weld. You can add it from that. Okay, so by that way you can add a fillet detail for the weld sample. By the same way, for the surface roughness, you can add samples for the surface roughness like that. Select from standard samples and the standard configuration for the surface roughness, and many different levels or like that. Now let's discuss how to make a center line, center point. So to create a center line or center mark, you should have an arc or a circle. So by selecting this circle, automatically you will get the center mark like that. So you have a center mark like this one. Okay, and for the center line, you will need to select two vertical lines like that. So you can create a center line. You can extend it by that way. So you can move it up, down the end point to extend the center line. And you can use a center line by defining 2 points. So if you would like to connect, for example, between this point and that point, so you can create a center line by using 2 different points. And one more thing for the this type of center line, it's has many options to use it. So for example, here for that one, you can make a center line, circular center line, by selecting a different circles like that. So automatically it will detect the center line of orientation, and you can make a center line by that way. Okay, here for example, you can make a center line for those vertical lines. By that way, you can make a center line for those circles, and you can align. For example, you have a center line here. You would like to make it aligned with those lines. So by right-clicking on it and from edit, you can make it aligned to edge. So when you select this edge, the center line will be fitted to this edge. The same thing, you can do it for that one here, for example, and you would like to align it with the edge. So aligned this to that edge, so the center line will be aligned like that way. Now another option for the this type, which is centered better, we need to get or create a part. Like, let's create a new part as a flange, for example. So from here, let's create a center line for a flange. Let's make a rough dimensions. Those are work lines and construction lines, and here we have the here that's the flange facing, for example. Okay, and click finish, make a revolve, and now we have this flange. Let's create some holes here. So from this point, let's create a hole, finish. And by using the hole feature, you can use a hole or make extrude cut. It's the same. So by selecting this and decrease the value to, let's say, 4 millimeters. Okay, it's okay now. You can make a pattern, a circular pattern for this hole around the center line. Let's make them 8 holes. And now we have this flange. Let's save it as flange. Okay. Saving this flange, let's add it inside the drawing. So let's open a new sheet, another sheet. Let's sheet number 4. And from here, let's import the view of this one. And let's take a look from the top view, change the scale to like that, or make it 5. Here, by using this type of center line, if you select any circle referred to the center line, like that one, and select the inner circles like that, you will get a center line which indicates the bolt circle diameter of circles. So after that, you can click on create to create it by that way. Okay, now let's create it by another way. Here, if you right click on that view, you will get this shortcut menu, and from here you will find an option as automated center line. When you get this form, you can select the type of center lines like that. You have holes, you have a circular feature. So when you click on OK, automatically you will get a center line for those holes in one time. So if you have a huge number of holes, and instead of making that way, which is selecting each hole like that, so you need to cross all holes, select them all. After that, click create. There is another way to create that, which is selecting the automated center line, and from here select circular, select sketch geometry, and select all cylinders and holes. When you click OK, now you will get a automated center line for holes. Let's check that if we have a huge number of holes. So let's come back to this hole and decrease the diameter of this hole. Let's make it 1 millimeter, for example, and increase the number to be 32 holes. Okay, let's increase it a little bit. Let's make it 2 millimeters. Okay, so we have that number. And when you come back to the drawing, if you try to create holes like that, you will get you will be tired if you try to make all holes by that way. But in one time, you can make it by using, as discussed, the automated center line. Just select circular pattern and select sketch geometry, select holes and all cylinder shapes. Now you will get all centered points like that. Just add a center line to here, and now you can select the bolt circle diameter or add it to your drawing bar by that way. Now let's discuss how to make let's remove this. Now let's add a bill of material for this part. How to add a bill of material and modify to this bill of material. And that's the last part of the drawing, inshallah. So from here, let's select the part list and select the assembly of the part. So let's select any views of those which related to the assembly. So any view. And from here, you will find some options like the bill of material view, if you would like to make it as a structure view, which include all parts, or make this view as a detailed view. Okay, so this detailed view, if you make a structure view, you will get this bill of material like that, which include the part name, which is fixed Joe. Here, if you let's make it again. the structure view will include the item, quantity of parts, and the part name. Here you would like to include some other values like adding the material of this part, adding the weight. So how to control that? If you are using this part list, automatically you can make a modification here by opening, double-clicking on the bill of material form like that. And after receiving this one, you will get this form from the part custom, so which is column choicer. So you can increase the number of columns and modify the columns. So from description, let's remove the description, and from here, let's add the part material. So from here, let's select material, and let's add it to the list. And for the mass, let's add it to the list. Now we have two new attributes or columns, one of them for the material and the other for the mass of this material. Now let's modify on that. For the item, let's change the width of this. Let's make it 25. And for the material, you can modify that, make the material text inside the value and the heading, they are on the middle, so they will be aligned like that. And for the mass, if you make a modification here, you can change the value here as weight and apply the units and make the value is aligned. Make the unit string if you would like to include it or remove it, so it will be in kilograms, so you can make it like that. Okay, so you can figure that it will appear on the top view. You can change the width, let's make it 30. No problem. And when you click on OK, now you can change this part list. So by that way, you can include other columns and to your table. So how to make your own bill of material, list, which include as a default the required fields. So again, so from Manage tab, let's open the Style Editor. Okay, and from this Style Editor, let's open the parts list here. And here you will find the default part list. Now let's create your own material part list. So from select parts and create new. And here let's create this one, SEG. Okay, so that's the new style that we will generate. And for this style, let's modify this table content. So from the column choicer, let's remove the description. And let's add the material. Here, let's add the material, add the math, and let's add another property like a volume, for example. So let's add a volume. Now we have, you can move up and down for the cells. So you can move this one up and down like that, move the mass down like this, make the volume before the mass. So you will have those columns as a default columns. Now click on OK. Now you have those fields will appear like that. So item, if you would like to change the heading of the column, you can change it from here. So let's make it weight. That change the width. Let's make it 30. This one, let's make it 30. 30. Item, let's make it 25. 15. Okay, and you can make a filter or grouping during that, and we will discuss that on another part. You can change the title of this one as a material parts list, okay, and click on save. Now, if you would like to create the bill of material directly from here, just select the part list. It will appear here. So you will select the CAD Solutions part list, and when you click on OK, you will get this part list by that way, and the volume here will appear like that. And if you would like to make formatting for that by removing the units, you can make it by that way and click in OK. Now you have the volume, weight, and all of that. So by that way, you can create your own material part list. The columns, you can define the columns by using the style editor. Okay, now let's discuss another project. Let's please close this one. And I would like to show you something else regarding the bill of material sorting and data sorting. So from this project, let's move to another project from browse. Let's come up here and select this project. And from here, if you open this project, if we open the drawings of this project, you can figure that we have a different number of supports. Here we have 145 drawings, and each drawing of those include an assembly. This assembly for a pipe support. Okay, each one of those with a different dimensions, and we would like to. That's for a C channel, for example. Another one like that. That's a C channel. So if we open this one, it's IBE with a different dimensions. Okay, so we need to make a list for a part list for all of those parts here. Now let's create a new drawing. So here let's create a new drawing, and let's import the assembly of all of those parts. Here we have assembly. Let's open that assembly. Okay, this assembly include all of this project parts. So you can figure that you have all assemblies inside this project. Okay, and we need to get a bill of material for all of the project in one time. Okay, so how we can do that? So from here, let's modify the drawing size a little bit. Let's make it A1 and make it portrait. And from here, let's base the view for the assembly. We have the complete assembly for this project. And let's move it a little bit outside here. And from here, let's create a bill of material for this assembly. So from here, let's create a part list and select this one. And in case of selecting the structure, so here we will discuss the difference between structured, and the parts only. In version 2023, you will not find the structure legacy or part legacy. Those types, which is structure and the parts only, will cover what we will talk about. So for the structure, if we select a structure, you can create a bill of material for the structure. Here you have the part name for each support. So the structure will give you the main assemblies only without the levels of detail. So if we create another structure here, but select all levels of detail like that and click OK. Now when you click on this bill of material, you will be able to make a sub detail for the content of each bill of material. Here, for example, the first part includes item 1 of 1 and item 1 of 2. So when you click like that, you will get a sub detail for each sub material, sub assembly. Sorry. Here for this assembly, you have some of items inside this assembly. That assembly, you have some items inside it. So if you would like to make a sub assemblies with different levels, so you can control that by a structural assembly with controlling the level of detail. That detail, here we have this bill of material of all items, all parts. Okay, and if we move it a little bit here, you can figure that we have here 290 different parts. Okay, so now let's make this list, including the description of the item and the material and weight. So from here, let's remove the description and part number, and let's add another attributes like status and material, from material and mass. Okay, so from here we will get that. Let's change the width of that to 15, change the width of that one 5, and for those let's change to 5 and vertically aligned like that. And for that one, let's remove the units. So from here, let's remove the units and make it like that. Okay, make it centered. So format cell, make it centered, and let's increase this one a little bit. So from here, sorry, let's increase the width. So from here, make it 65. Okay, now let's click on OK. Okay, now we have all parts in detail. We have 290 parts. If you take a look to the name of each part, here we have an HEA 120 with the length 1 meter and 0.2, the material and weight. So if you find some other parts with the same description and the same data, and you would like to make a sorting by, so you have here a large list. You would like to merge here the identical items. For example, let's say that HEA 120 and with the same name, and you would like to merge the same parts here. So from here, you can make a row merge setting, and from the merge setting, you can make the merge for the parts that they have the same status and same mass. So from here, if you click OK, now if you take a look to the list, it's decreased to 75. Okay, let's do that again. For example, here we have from 1 up to 290 parts. So to make a summation or merge the parts that they have the same information. So from merge option here, you can make a merge for the identical items which they have the same status and like that. So when you click on OK, now you have a shorter bill of material. You have 75, and the identical items will be assembled here. Now, if you would like to make a sorting, for values. So you can make a sorting from A to Z. So from here, by using sorting and select status, so you can rearrange again this from A to Z. So arrange the style like that, and rearrange the items by selecting the column and rearrange the parts like that. So by that way, you can rearrange the bill of material, and that will be reflected to the 3D model. Okay, now I think we make the last step for discussing the bill of material option and how to create or modify the bill of material features, make a merging for the identical parts. Now we can make an open discussion. If you have any questions, we can discuss it, inshallah, on the next 2 minutes. To define a border, you need to make it as we discussed, all of those things which we discuss it, like making a parametric or custom parameters or all of that, you will not be able to import it from the AutoCAD. So it's one time, you can make it for one time in Autodesk Inventor and use it after that. Let's say it will take a day from you, okay, but you will use it all the time after that. So it's better to make it, you can import it from AutoCAD, but you will lose a lot of things. But if you make it for one time for your company, you will make your border and title block, so you can use it, take it, copy paste from drawing to another, or make it as a reference one. So, and you can modify the properties of the drawing, like adding your logo, adding custom properties, like custom properties here, like we discussed. So all of that you will not be able to deal with it in AutoCAD. So from here we have the first part. If you take a look for select the balloon, and from here if you select this part, you will get this balloon automatically, and that one is 42.2. So from here, if you this item is 26. If we measure the length of this one, for example, it's 600 millimeters, and I think it's HEA. So it's HEA 100, I think. So the item number 26. So let's come back here to item number 26 here. Item number 26, we have the quantity is 19, and the description of this one is HEA 100, and the length is 600. Okay, so the number of this one is correct. And the second one, which is 24, and the length of the 24, it's 40 millimeters. So let's go to 24. So 24 HEA with a length of 400 millimeters. Okay, there is another two levels in Autodesk Inventor. The first level, which is the beginner's level. In this level, we discuss what we discussed on level 1, which is the day 1, which is 2D sketching, 3D modeling, making an assembly, making constraints, the sheet metal, and preparing a drawing. There are different levels of Autodesk Inventor, like advanced and professional level. In those levels, you can make you can make by using the frame generator, you can make a simple steel structure. You can use the dynamic simulation. You can use the finite element. If we come back again to the first day of the training, because we discussed that on the first day here. Here with the first day, we discuss how to make parts assemblies. After that, discuss how you can make a piping, harness, cables. You can make a steel structure. You can make a presentation videos. You can make a dynamic simulation, finite element for steel structure by using frame analysis tool. You can make a stress analysis by using the FEA tool. You can make a design calculation by using the design tool for power transmission systems. You can use the Inventor Studio to render the videos and render the images for your products. So those things could be discussed for the next levels. And one other thing, which is the how you can use the iLogic to program the parts. For example, here, if we open this part, here you can figure that the size of this camera is HEA 100, and that's the length, width. Okay, and the dimensions will appear here. If we open this part, for example, and from iLogic tab, iLogic browser, you can make a modification for this part. For example, if we change the size of this beam to 160, you can figure that this item will be updated based on a programming inside this part. So the size is changing. And if you would like to change the length of this one, let's make it 750. So you can change the length, change the height to 800, change the material to steel 36, change the quantity up to 10. Okay, now you can figure the part number name automatically change it based on the programming here, because we have you can prepare on the advanced level. You can make parts, those parts including some iLogic rules, okay, to describe the dimensions and the values. You can make a database for each item to make it read from another. Now, if you come back to the drawing here, after updating this part, if we come back to the drawing here, you can figure that the dimension automatically changed here and there. So the width become 570, and the height and the bill of material shall be changed. So the size of the beam changed to HEA 160, and the length changed to 750, and the second camera length and the material changed to steel 36. Now let's come back to the assembly, that one again, and change the dimensions to 100. Okay, you can figure that the size changed. Now let's change the length to 1000 millimeters, change the height, change the material to steel 44, and the quantity to. Okay. That's an advanced level, how you can make that, how you can make a program. So Here the drawing automatically changes, just make some adjustment for the dimensions, and the bill of material here, the description of the item will be changing automatically, and the material the same for the weight, and the required number of items here will be automatically changing. And let's open the project of today, which is including the English spanner. And let's create the balance on the assembly. It's just saving some seconds to close, because this file including a huge number of drawings. It's 145 sheets, so it takes time during saving. Now after saving, let's close this. Okay, let's close this one. Don't save. And now let's move to our project. So from here we can just come up and day 4. So let's select day 4, and let's open the saved drawing. Now we have this drawing. So from here we have this part list, and from annotation, let's select balloon. And from balloon, when you select this item, automatically you will get that balloon like that. Continue, select this part and continue. That one, continue, and the bin inside. So let's select it from here. That's the bin. Now if we take a look, item number 5, if you come to the bill of material, item number 5 indicates the tapered bin, and here the material, and that's the volume and weight. So the quantity of this one, we have 2 pieces from the tapered bin. And item number 4, here, that's item number 4. So for item number 4, we have a 1 piece, the quantity 1 piece, and the part number, or the name of this part is a plug, and here the material and the volume and weight. Item number 3, where is item number 3? This handle. So let's come back here. Item number 3 is handle. Here's the material, volume, and weight. The same for the other parts. So you can add the balance here on the 3D model by that way. The bottom one. And for the bin inside, you can do it like that. You can make aligning for parts like that. The part number arrangement depends on the hierarchy in the assembly. Okay, so you define this part as a part item number 5. So it will be item number 5 unless you make a modification. Like here, for example, if you moved this one up here, so after that make arrangement again, so you can make a renumbering again. So from here, item 1, 5, 2, 3, but you would like to make this one re-numbering again. So from here, the tapered bin will be number 2 after making a renumbering again. So 1, item 2, 3. So in that case, here, okay. Hello.
Hello. Okay. So this part number, it is by default based on the hierarchy it is assigned. We cannot edit this one, right?
You can edit. If you would like to edit, you can edit, but it will be at the default. For example, if you would like to make this item number 15, for example, okay, you can figure that now this cell takes a blue color. That means this cell is including a static value, not a dynamic value. You modify it by hand. So if you make it again as a static value, it will be come back again to 5. So if you change it for 7, for example, it will take that value. If you click on accept, it will take number 7, and it will appear on the drawing on balloon as 7. Okay, but you will be informed on the bill of materials that value modified by hand as a static value.
Okay.
So for example, here, let's make it A1, A.1, A.2, and here B.1, B.1, and delete 3, like that. So that one will be 1 and 2. So you change all of that manually. So you give them a part number. If you take a look to the balloon, it will take the same value.
Okay, thank you.
And again, you will find it on this with a blue color. That means it's a static value. You changed it manually. If you would like to make it again dynamic, just select it and remove the static value to make it again with the dynamic values. For the dimensions, if we have open a new drawing, for example, and let's add a view. Let's add a project view for the fixed jaw. Let's have the fixed jaw here, and let's increase the scale like that. Okay, let's make it 1:1, no problem. Okay, we have this fixed jaw like that, and we would like to add a dimensions automatically for this one, or for the relative model annotation. If you select this one, automatically all dimensions you imported on the 2D sketching here will appear like that. So you can select what is required, like that. So you can select the dimensions that required and you would like to keep it in your drawing. So you can select all or select parts. After that, you can import all dimensions. After that, you can make adjustment. So by that way, which is relative model annotation, you can import or use the dimensions from the 3D model itself directly. So here we have this value. Just you can make some adjustment to the drawing by that way. Okay.
Okay, and and one more thing. For
Yes.
example, this project. For example, we have received this project for this. I'm saying this example. This hammer item, we have another project we have received. Some minor dimension changes are there. So we can take the old existing model and we can modify it. So the drawing, the 2D drawing, 3D, everything will change automatically.
Yes,
So,
sure. Here, for example, let's open this part, and if you try to change the lens to make it in instead of 80, let's make it 100, for example. So this value, let's make 100 millimeter. So you can figure that the end will be extended a little bit like that. If you come back to the drawing, it will be updated and the dimension will be updated. If you open the assembly itself, you will find this value will be updated. So the 3D model, here's the power of the 3D or CAD software, which is any update on the 3D model will be reflected automatically, and that will be reflected on the properties of this part, like the weight of this part. The weight will increase because the volume of this part increased. So the volume items, the density, you will get a new weight instead of the old weight based on the change of on the dimensions of this part.
okay, so how we will manage the folder management? For example, we have saved this folder for project name XYZ, and we created all 2D drawings and 3D model, everything in one folder. Suppose we are taking as a new project for
Yes.
another ABC. So we can copy the old folder and make it to a new folder. Then if we edit in that folder, it will affect the other folder also. How it will work?
Okay. Okay. Here, as discussed on the first day, the project information here. Let's close this one.
Okay.
Okay. Here for the projects, as discussed, you may have more than 100 projects you are working on.
Okay.
So to define the project, you should select the IBJ file, which defines the location of the project, the path, and that will define the workspace where you are working. So that folder will be your project folder. For example, in that case, we have Day4. In this folder, we have some other files, like we create a bearing bracket, for example. We have a bearing bracket here. We have an English spanner project, so we can create a new folder inside that one, like an English spanner. So let's take a copy from this one, create a new folder, and inside this folder, let's collect all English spanner parts like that and make them inside this folder. So here you have some subfolders inside the main folder, okay, and you are dealing what's inside this location, okay, which including this one. So if you would like to create a new project, for example, let's make a new project, let's say Day5, for example. So you will take a copy from this project as Day5 and make a paste here. And from the projects, you can rename the project name here, by the way. So let's make it Day5. And inside this project, you will find the Inventor IBT IBJ file, which is that one, you can change it as day 5. Okay, so we have a new project here called day 5, and from here you can open the projects, and now you can browse for this project. So select the folder, which is day 5, and select that one. Okay, all of your modifications should be inside this folder. Don't open any part inside that project, because if you open any part and make any modification, it will be modified on the workspace location, not on the current project location. Here, for example, now you will get that folder, which is day 5. Inside this folder, you will find those parts. You can open, for example, the assembly of that one, and re-modify this part again by selecting the sketch and change the length again to 80 millimeters back, and now you get the modification. So you can take a copy from your project. That's in case of using AutoCAD. Which are related to SEG software, we will discuss that. It's differ a little bit. But here with Autodesk Inventor, you can take a copy from your project, rename the IBJ file, which is that file, the IBJ file, which is define the location of the project. After that, you can browsing for it from project browser here and select the location project. After that, you can work on this project. Okay.
Okay. Thank you.
Thank you so much. How to complete the total weight in bill of material, also transfers the bill of material in Excel file. Okay. The total weight of the bill of material, you will not be able to collect it on the bill of material, but you can make it by another way on a text. As we discussed, you can make a text here, for example. This text, you can make a property for the material, like here, the model, physical properties for the model. You can select mass and select the precision of this one, and you can include the mass of this part. So you can collect the total weight of the assembly and put it at the end here. So the total weight of the material can be appeared here. But in the table itself, it's not an option to add the total weight of the part. You can make it by using that way to collect the total weight of the assembly. The next part of the question, how to export the bill of material to Excel format. So from here, if you open this one and make a right click, you can export the table. So from here, you can export the table in XLS format. So from here, let's make it BOM and select the location. Now the bill of material will be saved to the project location. It's in day 5. Here you will get this Excel sheet as a BOM. Now you will have this Excel sheet, and you can make an equation here to sum. So you can make summation the previous values like that, and now you can get weight of, because we have a kilogram here, it's not a text, so we need to the kilogram units from that one. So you can make a summation here. That way you can get a summation for the weight of elements. Let's do this one again. So you can get from the summation of values from the Excel sheet itself by that way.